there's two names that you'll run into. One is Potomac Science Center, and that is the name of the building. And the building includes PERIC, Potomac Environmental Research and Education Center. It also includes some elements of geospatial training. There's some rooms there for that. I'm not sure exact title of that center, if it is such. And then also there's public space. So this, looking at this, and I'll talk about this. Do I have a mouse? Oh, there it is. Okay. Looking at this lower plaza here, this is public space which opens inside to about 500 square feet of display space. So we can actually have rotating exhibit. We're still working on what we're going to have there. There was not a lot of money included in the building budget to actually outfit the space, so it's kind of, we have ideas and we'll have some sort of displays there when we open officially, which now looks like the fall, the latest I've heard. And then on the first floor here, actually that is a big multi-purpose room. So we can have gatherings like this in that room, or other relevant things. We can rent the space out to relevant activities, etc. So in addition to just the research, and there are 2 teaching labs there, as you'll see in a minute, so forth. So it's going to be a great resource for the university and for the community there. So to give you an idea, sort of a bird's eye view of things, this is looking north, mostly north, a little bit west, up the tidal Occoquan River. And as you may know, there are numerous bridges in this area. There's Route 1 bridge, there's the Railroad Bridge, and there's I-95 bridge. And then a little further up, there's the Route 123 bridge that goes right into the town of Occoquan. This is a new town development that's been there for a little while. And we are right at the northern end of that. And the rest of that empty space is actually slated for commercial buildings, some of which might be related to our activities, but it's not university space, it's developer space. You can see there's a harbor there, which is for people with big boats and big pocketbooks. Okay. We probably won't have any space there. But at any rate, our mission, to utilize it. And one further thing about PERIC, it is now in its 7th year. So it's not tied directly to the building. It started existing 7 years ago. So, but we were all the members of PERIC are in different places in their own labs. So it's going to be a chance for us to get together. Basically, we want to use the tools of scientific research, restoration, education, and policy analysis to help society understand and sustain natural processes in our aquatic systems and watersheds. So traditionally we've had 3 areas of focus. The main area was restoration of the Potomac River and Chesapeake Bay. In other words, doing science to underpin and to inform that management. We also have done research over the years looking at sustainability of natural ecosystems in suburban areas, particularly with regard to streams draining suburban areas and how best management practices may or may not help to protect the ecosystems, the stream ecosystems in those areas. Not so much on global climate change, although early on we did have faculty members working on that. So some of the important research questions that remain on the restoration is trajectory of recovery in shallow water habitats. Are we in fact on path to attain recovery? And we've done a lot of work in the shallow water habitats of Ghosted Cove and more recently in Hunting Creek. Just general understanding of tidal freshwater ecosystems, which is kind of an unusual habitat if you think about it. We think of tides as associated with the ocean, and therefore we think of some level of salinity. And it turns out that in In the bay proper, there is mostly brackish water, a mix of ocean water and fresh water. But in our part of the tidal Potomac, the freshwater input keeps all the salt pushed down to about Quantico. So the area that we're actually in, and that we've done most of our studies, is actually this rather unique system called tidal freshwater, which has elements of the fauna of both, but in many ways functions more like a reservoir than like an estuary. We've begun, the past several years, we've looked at hormone pollution and micropollutants, and we're getting more into E. coli with Hunting Creek in particular, and also some of the streams around. Okay, so to give you an idea of, again, of where the new facility is, it's right down here, right on, it's across the river from the actual Belmont Bay. The development we're in is called Belmont Bay, but it's actually across the river from the real Belmont Bay. But it's very accessible. You just come down 123 to Route 1, and then you have to kind of do like a U-turn there to get across the railroad tracks. But it's like half an hour's drive from here. It's actually a little closer than the Prince William campus is to here. It is in Prince William County, ever so slightly. This is kind of another view, and a minute ago we were looking at this area here, some of the condo buildings, the marina, and then we're actually over here up against what was, until recently, a golf course. It's still a golf course, but it's been closed as a golf course, my understanding. So we're not sure where that's going to go. It may reopen later as a golf course, but for the moment, that's sort of up in the air. But another feature that's very important here is that we're right near the Occoquan Bay National Wildlife Refuge. So that's a great asset in terms of teaching, research, education. We really value that. And we're right across the river from Mason Neck, which is a even larger tract of National Wildlife Refuge, State Park, Bureau of Land Management, basically a lot of natural lands that can be researched and in various ways. We're near a VRE station. Doesn't actually help too much because, of course, VRE goes inbound in the morning and outbound in the evening. So if you lived in Fredericksburg, you could commute to our facility. If you lived in D.C., you're going the wrong way. So there is like 1 or 2 Amtrak trains per day that can get you elsewhere, but it potentially is going to be a good asset. But this kind of gives you a flavor of all the natural areas around. All this green is, land that's managed as a natural feature, parkland and that sort of thing. And what isn't shown in green is actually another large naturally managed area at Fort Belvoir. So all of this land here is really managed as natural area, and even the fringe around this peninsula. So you can be out here in the river and you don't even know that Fort Belvoir is up there. So it's a really amazing tract, within, we're really embedded in this really nice matrix of nature for nature study. Okay, so here's what we're going to look like if you're in a helicopter or something, or you're poised up right above the river looking toward our facility. Again, you'll see the plaza, you'll see the lower display area, the multi-purpose room, and then above that are 2 floors of offices and classrooms. The labs are kind of on the back end of the building, away from, so that on the right is the office wing we just saw, and to the left is the lab wing. So the lab wing runs back away from the river. And of course the elevator and so forth are in the middle, in between. This is what it looked like a few months ago. Again, you see we're pushed up against that golf course pond, and we do have a dock in the pond. We have a dock in the river, but it's very limited in terms of access because the river right in that area is very shallow. So we won't, at this point, be able to bring a large draft boat up. That will be something that we'll be trying to remedy over time. If we put a pier out 100 or 150 feet into the river, we can actually get to a dredge channel where we could bring large boats up, much larger than anything we have. So there's a lot of potential there as well. It only likes a page down. So again, there's the layout. Here is the, come on. Up here is the building itself, the office wing, the lab wing. Then we have to build a parking garage because this is a planned community. So even though we probably will only have 30 or 40 cars per day there, we had to build a 200-car parking garage. It was related to both the fact that it's a planned community and also state, because we have 50,000 square feet, even though it will be sparsely populated relative to an office building, we have to build parking as if it was an office building. So, anyway, that's part of the package. At any rate, you see there's also an interesting feature. The Potomac National Heritage Trail currently runs through the site, and basically we've rerouted it around our building such that it will have even better visibility of the river, and it will actually run on an elevated walkway across the top of the plaza and then around back. It's slated to run all the way from D.C. to Yorktown, but this is one of the few places that it actually exists. So it goes down to the border of the refuge, and they haven't done anything in the refuge, so it actually ends at the refuge, and then it runs around a little further upstream toward Occoquan. And that's the piece that we're on. Okay, these were some of the drawings. This was the groundbreaking. These are the faculty and scientists that are going to be working there, and you'll see some of the folks are in the audience here today. And this was a picture I took just a couple of days ago. So you can see that all of the floors are up, the sheathing is on, they're working on the inside, and in the background that's the tidal Potomac, and in the foreground that's the freshwater pond, and I'm standing on the former golf course. And no one's hitting any golf balls at this point. So. Okay, and this is, again, some descriptions of what we have there. We're going to have eight PIs, most of them professors. So we'll each have like a 700 to 800 square foot lab space, plus we have a lot of support facilities that we'll share. We've got room for offices for graduate and undergraduate researchers, classroom space, and then another kind of unique thing to Mason for this is we actually have dedicated space for bringing K-12 students in as groups or individually for programs. And we're already doing programs, as you'll see in a minute. This will give us on-site space to accommodate those. And then we want to have other programs for the public. We're doing some citizen science programs related to river monitoring, so those will be housed there. And we'd like to offer a much broader range of professional but also citizen naturalist development courses, like a course in dragonfly taxonomy, and for hobbyists, because that's becoming the next thing. Like there's bird watchers, and that's very, very popular. But now some people are going to dragonfly watching, if you will, or dragonfly as a hobby. Okay. So again, it's kind of a laundry list of all the rooms. And the Wildlife Refuge is a great asset. It's almost 1 square mile, 580 acres, including wetlands, uplands. One of the things we've already started doing is taking different groups out on the river to experience it. Of course, we have the K-12 groups. They usually don't actually go on the river. They stay shore-based, but we do take some of those out And we also have, I've taken the retired faculty group at George Mason has gone out. And another group we took out were the Virginia State delegates from Prince William and Fairfax County. And you see Delegate Bulova is on the left, Delegate Ligenfelter is in the back, and Delegate Anderson is in the red shirt. And the gentleman on the right is, I think, Delegate Anderson's staff member. Laura Bursa, technician, is in the foreground. I'm in the background. I think Cindy Smith took the picture. An interesting thing that's happened since then, I'm going to kind of brag about it a little bit, is that Delegate Ligenfelter has recommended me to be the new citizen member of the Chesapeake Bay Commission from Virginia. There's only one citizen member, and the rest of the public officials are okay, well, we'll see. It's got to be approved by various people, but I think they're trying to, the point was they were trying to bring more scientists in, and since all the other positions are like allocated to legislators, the citizen member is kind of the one that have to go with that right now. So anyway, that should be fun. One of the things we're trying to do with this citizen science thing is to explore some new ways using new technology of measuring water quality. So one of the things we're doing is having them look for aquatic plants, and we give them a guide to identify different ones. And that's certainly a very helpful piece of information, because it's hard to go around and hit all the spots as a scientist. But if you have like people out there looking for them, that really amplifies your database. Another thing is everyone now has not everyone, but almost everyone has either just a digital camera or a cell phone, a smartphone that takes pictures. So one of the things we want to do is try to use the color of the water and the turbidity of the water as determined by a cell phone camera or smartphone camera or digital camera to tell us something about water quality. So, and this is not unlike sensors that we as professionals use. It's just they're dedicated for, and they're tweaked and optimized for that. In this case, we're trying to use what people already have. And so one of the ideas, and we're just starting to collect data on this, is to have them have a clear jar, fill it with water, put it next to a color wheel, because every camera, has its own sensitivity for color. So you have to have a standard to assess. In fact, if you look at the back of the room, you'll see that the colors look different than they do at the front of the room. So we're going to explore whether we can use that as a means of getting more data on water quality from citizens. Okay, these are some of the research studies that we're doing right now. And when I say we, certainly Dr. DeMutzert is a very important member of the team, because she and I actually complement each other and take different aspects. Dr. Foster, Dr. Jonas, and so forth. So I've got a lot of other stuff here, but as usual, I tend to ramble on, so I'm just going to show one more slide here. I'm going to let Kim talk about her stuff. I'm not going to talk about Gunson Cove, because that would take forever. There's Dr. Foster. He does his chemistry stuff along with Dr. Huff. And Dr. McBride is on sabbatical right now, so I won't spend any time with him. But he's going to be down there. But the other thing is the K-12 studies that Dr. Smith is doing, Cindy Smith, and Prince William and Fairfax. We're looking at that. And if anyone in the audience would like to participate in this, just send an email to Cindy Smith, and she will enroll you as one of the interpreters. So with that, I think I'll just stop, and if there's any questions, whatever time I have. Thank you. It's up to any questions or? Yes, sir.
What about power sources? Are you guys using alternative sources of power? Solar.
The quick answer is no. We were trying to populate the parking garage with the top floor with solar panels, and Dominion was going to give us a grant and all this stuff, and it didn't work out for various reasons. So water, I think we're capturing our water that's hitting the building. It's going into a cistern, and we're using that for watering the thing. But as far as power goes, I don't think we're doing anything unusual. The building, we aspired to be LEED Gold, but I think because it's a lab and you have to exchange air all the time, you just get killed on the HVAC stuff. So we're not going to be anything. We're not going to be the Chesapeake Bay Chesapeake Bay Foundation building. Thank you.
Thank you. All right, our next speaker has already been mentioned, and we put these two speakers together because they are working closely with each other. So many of you know Professor Munster, who is our professor in environmental science and policy, and she's going to tell us about fish research in Potomac River tributaries.
Thank you, Lisa. Yes, so that was a good introduction. So let me go to the next slide, as it will let me.
Slow.
Very.
Page down seems to work the best.
I see the thinking circle there. So you can already see some images for as long as they stay up of some fishes that we encounter very often. The banded killifish, the beautiful two fishes over there. And the other one was river herring, alewife or blueback herring, that I've spent a little bit of time on as well. I just had my name on the title slide, but I want to make sure you realize how big of a group of folks are actually involved in these projects. First of all, Chris Jones, obviously. The other collaborators, either past collaborators, Don Kelso, Richard Krause, used to actually lead the field component for the fish research. And current ones that Chris already mentioned as well, Greg Foster, Tom Huff, Bob Jonas, and in my lab, also actually contributing to some of the stories I will be telling in this presentation, Joris Vanderham, CJ Slick, Amanda Sills, Beverly Bachman, Casey Person, Sammy Alexander, Christy Lewis, Peter Jacobs, Katie Salbach, and actually numerous other volunteers. And the funding agency of two of the big monitoring program we have are up here as well. So what I would like to talk about are these large monitoring programs that we run, but also really focus on the fact that we do have this standard monitoring that we repeat every year, but there's a lot of mainly student projects that then take the research that we're doing already, the trips that we're going on, and make a component of it their own. So there's all kinds of smaller projects that basically spin off these monitoring programs, really providing a very rich research program in that way. So the Gunston Cove fish community is something we monitor. The fish community in Hunting Creek, and river herring spawning populations in both of those locations, with a general research question of what the ecological condition is of these freshwater tidal ecosystems. And actually it is centered around the receiving effluent of treated wastewater, of wastewater treatment plants that are located both here and here. When I created this presentation, I realized halfway into this that I wasn't going to have time to really spend a lot of time on Hunting Creek, so this is going to be mostly focused on Gunston Cove. A little bit of background, though, I mentioned already. This is very much focused on how do these ecosystems respond and thrive while they're actually receiving effluent from wastewater treatment plants. And the Gunston Cove actually has been going on for a very long time. It started in 1984 after the Noman Coal pollution control plant that releases effluent in Powick Creek, that is a tributary directly going into Gunston Cove, removed a significant amount of nutrients from their effluent. And this study is really a study of the recovery of the system, of this hyper-eutrophication. Just at this point in time, it was dominated by phytoplankton. The Hunting Creek study is started relatively recently in 2013. It very much resembles what we do in Gunston Cove, but it has some additional components as well. It includes, for example, an ecotoxicology component. Some research has been done on endocrine disruptors in fish, for example, also a microbiology component, some of the things Chris Jones mentioned already. The anatomous fish run, so the river herring I mentioned is an anatomous fish. It actually spends a large portion of its adult life in salt water and then goes up into the estuaries, into freshwater creeks to spawn and back. So lots of problems associated with these fishes, overfishing, water quality problems, dams, and so on. So there's an anatomous fish component to both of these studies where we really try and track these populations and the size of these populations. So in Gunston Cove, these methods here have been, and locations have been consistent since 1985. There's open water trawls in the cove, 2 locations actually, and one outside in the main stem. You see some of the people on the crew here pulling in the net. You can actually, if you look closely, see the problem associated with these trawls now as a result of a good thing, the thriving of the submerged aquatic vegetation that we see in this area now, and you can kind of see that in this image. Because of that, it's hard to trawl, especially in this location, and in 2012 I started adding fight nets to the gear. That is what you see right here, and here you see a schematic of that. It's passive gear. What that means is we don't really move it around, but because it's tidal, the water will actually move in and out, and in that way it can actively catch fish. We also pull seines. You see an image of that here, so that's on the shorelines. There's smaller or larger beaches on the edges of Gunston Cove, and we collect different fishes depending on what gear you use. So it's important to use this combination of different gears. In addition to that, we monitor several water quality parameters, and also, of course, Chris Jones is in this area, so we have a wealth of information on even nutrients and various other components of the ecosystem. It's just not working at all. So I just wanted to highlight some important trends. So in Gunston Cove, the water quality improvements as a result of the removal.
Welcome to Blue Jeans.
Effluent, I don't know. Is that the computer that's doing that? Okay. All right. These water quality improvements really increased water quality and clarity, increased SAV cover, SAV, submerged aquatic vegetation, and this affected the fish community structure, which is what I will be showing. This figure that I included here is really, it's not really from the start of the study, but you can see clearly here, first of all, how long it really takes for an effect to be seen of any removal of nutrients. There's a lot of memory, of phosphorus memory, especially in the system, that will keep replenishing the water with nutrients until it is removed not only from the water but from the sediments as well. So what you're looking at here is the chlorophyll A that indeed over time, very late, remember it was already in the early 80s that the nutrients were mostly removed. At some point here, you really see that going down. What that means, water clarity goes up. You can see that in Secchi depth going up, so you can basically lower a disc to a deeper water level and still see it. And in response to that, we already are in a period here with what I would call medium coverage of the submerged aquatic vegetation. Really shot up in 2005 when a large portion of the bottom of the bay actually had light reaching it. So of course what I was interested in, and the fish data goes as far back as 1984, how do the fish respond to that? So to show it in different images, and these were created by Amanda Sills, who was a student in my lab. This is what it was in 1984. Then forward to 1995, you see that there's some SAV, so there was nothing in 1984, some coverage, and that is really representative of a certain portion of time, up to 2005, where the SAV coverage really took off. So we can really see kind of these three periods of SAV coverage in the Cove. And here in another portion or figure that I received from Chris Jones, that SAV acreage is shown here, the years that it was measured, here the colonization depth. So this, we don't really see the earlier years when there was no SAV in this image, but here is medium coverage, so you can see this, the acreage associated with that, and then it really shot up. You see 2003, 2004, 2005, and the years after. So really a shift in this high SAV coverage. So to relate that to fishes, I divided these years up in these three SAV cover portions, where I figured, okay, let's make the years before, 1993, there was basically no coverage. Now let's call this period medium, from like 1994 to 2004, and then let's call this full coverage from 2005 to the present. And with those tags, basically, add that to the fish data that were collected in the same years. Do we see changes in the community structure that are related to these shifts? And I indeed saw that. What you're looking at now is a MDS plot that's multidimensional scaling. It's a way to represent these multivariate data. Each of these points in the graph is an entire fish community of a year, kind of the average fish community, weighted by their abundances in Gunston Cove, collected with the seine nets. The seine nets were the gear used on shore, so it's very representative of what's going on in the Cove. And very neatly, these three categories that I based on plants, not on fish at all, splits out the fish communities in these three groups, because in a graph like this, the distance between the points really shows how much the community is similar to each other. So large difference, very dissimilar, close to each other, very similar. And you can see that those early years that I called no SAV years are very similar to each other. Then there's a shift to the next cover that I call medium, and those communities are very similar to each other. And then with the next shift again, these communities resemble each other and are dissimilar from the others. So this was an interesting find, because if I was just looking at abundance or biomass, there were actually no differences. The people that have looked into this before were saying, well, we don't see any effect of the SAV. But if you look at the community composition and community structure, really, you do see differences. And what I've added here are which fishes were mostly representative of these different time periods. And we see white perch and bluegill in the early years, pretty tolerant species. I can tell you they're still around now. But other species started to come in and really have a larger weight on the abundance of the entire community. Here we see some bay anchovy. That's still mostly an open water species, likes to filter out a lot of phytoplankton, so still a lot of phytoplankton in the system there at this point. Until the later years, banded killifish very much associated with SAV, a huge increase in banded killifish in this area. And we started seeing more and more larger predators, which may actually be a result of the increased water clarity. They have better chances at catching prey, and that's a good thing, because people that like to go fish usually tend to aim for the larger predators. So I was looking into these larger fishes, and then Amanda Sills, my student, was thinking, well, what about the larvae? We've actually been collecting larvae since 1993, so that's a really long record as well in these two areas. So actually, Chris Jones, he takes a zooplankton tow out on his boat, collects the ichtyoplankton, which is a fancier word for fish larvae. So we have these data sets both from the inner cove and from the main stem. Also, again, associated with water quality measurements, and again, all this suite of measurements that Chris Jones takes as well. So you can see this was later, and actually even exactly 1993, that was the first year of that second SAV acreage period. So Amanda only split her data in these two time periods. So also purposely choosing this split in time where there was a sudden larger expansion of SAV. And in the larvae, also sees this clear shift in community composition. We would really say larval assemblages, so which species are part of the larval assemblages, shift from that earlier period to that later period, as shown in this case in this cat diagram that also accentuates the differences between communities. And you really can see these two separated groups here. What's overlaid are various environmental variables. And what we see here, for example, the length of these vectors indicates how strongly an environmental variable correlates with this, the split of all the samples. And SAV area is indeed a very important factor related to these early and late split. You can see other variables as well. So here, these are nutrients, for example, much higher nutrient content of the water in this time period than in this one. So again, looking at what species were they mostly responsible for the differences or mostly representative for these groups. Then one interesting fact here is that the white perch actually showed up in the later area, which may be an indication that in the same catches where we saw a reduction of white perch may actually be the fact that we have a harder time catching it with all that SAV. So there's still a lot of adult white perch in the area as well. We just don't see that as well in the same catches anymore. But the open water larvae trawls really show a high abundance of these species in there as well. And this is gizzard shad, another species that came out to be increasing over time. What we saw as a representative of the earlier period is a lot of larvae of blueback herring. Now we do like blueback herring. It apparently decreased over time. And I'm going to use this as a segue into the next story, this may actually not be related to an increase in SAV that is bad for blueback herring in any way. It is really a species that has been facing a lot of threats from overfishing, from water quality problems in general, and this species has been in decline, which is seen in our data as well. So there's a lot of information that can be gleaned from these long-term monitoring programs. So as I said, let's segue into to river herring. Blueback herring and alewife are both called river herring. They're actually very hard to keep apart. Only my students can do it. And that's why they call it river herring. And a lot of the SPOC assessments is focused on this group of species, just because they're difficult to keep apart. We used to have them around here in great numbers. Anecdotal evidence talks about an annual catch of up to 1 million fishes. Chapman's Landing is very nearby us and where we set our nets right now. That was in the 1800s. Habitat degradation, overfishing caused the decline of these species. We don't have any dams right here on the Potomac, but that in general the population is larger. Chesapeake Bay would be its environment, and even more than that. So also dams for these anadromous species that need to swim up is a huge problem. So they were indeed declared a species of concern in 2006. They were actually petitioned to be listed as threatened. They are not, they figured out it's not that bad, so that wasn't found warranted. But there was also, through this, trying to figure out whether they were threatened or not, NOAA realized how little information we have on these species. So there's really a call now to find more information and really to have scientists include or try and figure out more about these species. Additionally, they did decide to, and in several states now, have a moratorium on the catch. That was here in 2012. We expect, or I can show you, we think there are already some effects of that. I'm going to go through this real quick. I'm running out of time. We set nets for 24-hour spawning run from March to May. We use that period to catch the fishes. We collect larval fishes here as well. So we look into long-term trends. What you see here is river herring, but also hickory shad, this larger one that we catch as well. So relatively similar is the data that we see. But then we know in 2012 this moratorium got established. So we are interested, of course, this one went up to 2014. We just really looked at the 2015 data. That would be the time period where you would expect some effect of the moratorium. And I can show you in a quick video what we encountered in 2015. And you can indeed see this is a lot more, and they don't want to play at the same time. So this is an underwater camera and an above water camera. Just the amounts of river herring that we found in that in the streams. And my student CJ made this graph to show that in abundances. What you see here is the creeks that flow into Gunston Cove. Alewife and blueback herring neatly separated because of her great skills. And you can see how much more we have in 2005. Now, one caveat, they're not showing this everywhere in the Chesapeake Bay, but I'm wondering, it's just this combination of water quality and overfishing. So we're, for a large part, have figured out the overfishing now by the moratorium. Maybe we do have the right water quality for them to return, and other tributaries in areas of the Chesapeake Bay still have other problems, and therefore they can't come back there yet. So I still think the moratorium likely has something to do with these data. All right, quickly before I quit, I can keep this real short because there's posters on what else than looking at abundance we do with river herring. Two excellent posters outside in the poster room. And with that, I take any questions. This was just made, what was it, 2 days ago? So we're out in the field again. And if you want more information, you can also check out our website, made by Christy Lewis. Any questions? If not, check out the posters, check out the website.
Okay, in keeping with our interdisciplinary nature of the water forum, our next speaker is from the Department of Civil, Environmental, and Infrastructure Engineering. And in your program, Dr. Parkier is listed, but she had something come up at the last minute and couldn't be here, but she was kind enough to recruit a volunteer to take her place, Graduate Research Assistant Jana Haddad. And we're grateful for her to present on this topic.
Thanks. So yeah, I'm a master's student working on this project with Dr. Bakir, who is a postdoctoral researcher in the civil engineering department. So we in the flood hazards research lab, which is led by Dr. Ferreira in the CIE department, are looking at quantifying storm surge by wetlands, and specifically in the Chesapeake Bay. So that is what I will show here is the fieldwork component of that, and a little bit about the numerical modeling aspect of it. But essentially, the big question here is what is impacting? How can marshes attenuate storm surge? What are the various factors that are involved in that? So yes, there are, if you get a storm, there are a lot of factors that contribute to storm surge, as you can see on the left-hand side. And then on the marsh side, there are a lot of factors that contribute to attenuating that surge as the water is flowing over the marsh. And so the bigger picture question is, can we use wetlands and marshes on coastlines as a natural strategy to prevent or mitigate wave impacts to erosion and flooding impacts from storm surge? That's the big picture question, and the more narrow question here is, how do the various factors in the marsh impact that attenuation? And how do we kind of separate those contributions? So this is an image that, to me, kind of puts into perspective the way things are interacting. So there's a storm here. There's also a high tide. This is one of our marsh sites, which I'll talk about more later. But the high tide and the storm, the marsh is fully inundated, as you can see. So we have the one on the right is overnight. That's not very clear, but trust me, it's fully inundated. Okay, so we actually have 4 operational sites. So the fieldwork aspect of this project is taking place on these 4 sites that are, well, 2 of them are inside up the Chesapeake Bay, A and D in the middle panel there. And then 2 of them are on the very southern end of the Delmarva Peninsula, B and C. And the field work, the measurements that are the focus of this presentation are all taken at the Eastern Shore National Wildlife Refuge, which I think is, so this is one of those 4. It's the very southern end of the Delmarva. So what you're looking at in the left panel is the southern end of the Delmarva. There's a little island called Fisherman's Island that's in the bottom left of that image. And then our marsh site is the Star, which is blown up on this right side. So we have a series of sensors and monitoring stations along a transect along that site. And it's about, I would say the transect is about 400 meters deep cross shore. And we have elevations of above mean sea level, above the marsh, ranging from 1 meter above and 1 meter below mean sea level. This site is dominantly Spartina alterniflora, I think, in the low marsh area, which is like closer to the shore, and Spartina patens in the upper marsh area. So that's our site. So along that transect, which is the transect that you're looking at in the lower panel there, is so along that transect we have a bunch of sensors, and there's kind of 3 categories of sensors. We have hydrodynamic measurements which include the current velocities of water, water levels, and waves, which are also high frequency water levels. And then we have a roughness category. So there we're measuring some biomechanical properties of the vegetation that we find, and we're measuring topography using high resolution differential GPS measurements. And then we're observing the site continuously using these hunting cameras that we've put on posts that are taking pictures every 15 minutes. So we encountered 2 storm events on this site in the fall, and luckily for us they were kind of back to back. So one of them was at the very end of September, and one of them was at the very beginning of October. So these are those 2 storms. And I guess the main takeaway here is in the upper image, you can see that the dominant, so the orange line is giving you directions of wind. And the dominant direction of wind here is north, in the north-northeast direction. So the first storm, most of the winds were in the north-northeast direction. And then in the second storm, they were kind of wavering around north. And then the blue line is showing you wind speeds, so they're ranging from 0 to almost 20 meters per second there. So that gives us a great opportunity to see what we're measuring during those two storms. So we're going to look at measurements of current velocity, and we're going to look at measurements of water levels and measurements of waves. So this is our setup for measuring currents. So for currents, we have one ADCP, an acoustic Doppler profiler, in the water off the marsh platform, and one in the marsh platform. So this is obviously the one that's off the marsh platform that we are either reinstalling or removing. I can't remember. So this is Dr. Pakir here. She does most of the work. So this is velocity and direction profiles, one profile every 10 minutes. And this is what we got. So those two storms kind of aligned in time underneath the storm image at the very top there, I think was the idea. And I think for me the takeaway from this is a couple things. The second storm was much stronger, so we knew that. The winds were stronger, and it's kind of a double-peaked storm. And it's more kind of, it's a northern directed winds storm, so it's more cross-shore along our transect than the first storm was. And the first thing that you see, so in the top velocity image, that's outside the water, or in the water, excuse me, and then the bottom one is in the marsh. So reduction in current velocities are apparent. But then the second storm, you still see some high water velocities even in the marsh. So kind of to be expected because it's a stronger storm. But another interesting question is, is there an impact of the waves on that? Are the wave velocities contributing to the velocity that's being pushed into the marsh? So this is our wave setup, and you see this. So the sensor that's outside this box there is a high frequency pressure transducer. It's a 4 hertz measurement, and so that's our wave sensor. So we were only able to capture wave measurements for that first storm simply because of the limited memory available in those sensors and the conditions that were in the field during this storm time. Actually, we were really in the field during the very, very beginning of this first storm, I think. And so we just weren't able to put as many sensors out as we wanted to. But so these are the wave characteristics, and the top plot is showing significant wave heights. The bottom plot is showing wave periods. So dominant wave periods are between 2.5 and 3.5 seconds. I think the peak significant wave height here is 0.35 meters. And so I think the key takeaway here is we only get, so the top line in the significant wave height plot is in the water, not on the marsh. And then the next three, W2, W3, W4, those are along the marsh transect inside the vegetation. So the first thing I see is that we only get wave heights, significant wave heights in the marsh when there's higher tide, when the tides are coming in, right? So when there's no tide, then there's no waves. So that's interesting because there's still a storm here, right? And then the next thing I see is that when we do have wave heights over the marsh, they're being attenuated. You can clearly see a reduction of wave heights along the marsh there. So what's more interesting is maybe water levels. So this is our water level setup you can't really see the sensor there. It's that black thing that's she's putting up along the post. It's an on-set hobo pressure transducer that we've set to measure once every 6 minutes. And these are the attenuation results. So this is attenuation of water level, so centimeters of reduction in water level over 1 meter of marsh length, or of distance, really. So, and the different colors, again, represent the different sections of the marsh transect. So I will note that the most interesting thing to me here is that the kind of like super, I don't know if you can see the arrow, but the super light colors are the sections inside the marsh, and the darker blue is the section in the water. So it's actually the distance between sensor 1, which is in the water, and sensor 2, which is just above the marsh platform. So those values are positive. That means that we're getting a positive attenuation, of course, right? There's a big marsh edge for the water to travel over. But then once it's inside the marsh, we see dominantly negative attenuation rates. And that's interesting because, well, why? Why are we not seeing attenuation at all? And our interpretation of that is that there's a strong, of course, there's a strong attenuation above the front edge, but then there's an increase likely due to the presence of a stream inside the marsh. So the stream is filling up, and really the negative attenuation represents water being accumulated inside the marsh. And it's not draining out fast, it's not draining out fast enough due to the tide cycle. So it's accumulating over the tide. And that's really the key takeaway there for me. The bottom plot is showing the same thing, but just over the marsh. So these are, again, values that are positive to negative as the tide is coming up and then coming back down, or going back out. That's the key takeaway there for me. And so the other aspect of this project is numerical modeling. So what we're working on is running simulations of these tidal marsh areas in a model called ADCIRC, which is a finite element hydrodynamic model. It solves for water levels and current velocities over an unstructured mesh. So this is the mesh that we're using. It's essentially the Atlantic out to past Bermuda and includes the Gulf Coast, and it simulates a hurricane or whatever strong wind event you want, and it calculates water levels and velocities. So our area is in that little red box, and that is the way that mesh is representing our Eastern Shore marsh site. So it's representing it at about a resolution of 100 meters. So along that transect, we really only have like maybe 3 computational nodes. And that's kind of a problem if we're trying to get any understanding from this model. So the goal is to use the 1 meter resolution from our GPS field measurements to increase significantly the resolution of the model mesh so that we can do some experiments on a computer instead of in the field. And I think that's everything there is here. I will attempt to answer any questions if there are any, but feel free to contact either Dr. Pakir or our advisor, Dr. Ferreira, if you have any. Thanks. Yeah.
So for your monitoring device, were you planning to use continuous monitoring device that can send signals to your computer instead of monitoring cars so that you will not be, so you won't miss out on safety events?
Right. I think that would be really cool. I think there's some limitations there with respect to the permit regulations. So we have permits to go into these marshes. And I think that that might require a power source that is a little bit difficult to provide, but I mean, that would be ideal. Yeah. Any other questions? Thanks.
Thank you. where's the computer? Let's see. It's here. Is that it? Right. Actually, let's save it to the desktop so you can take your. Oh, all right, wonderful. Go ahead. Okay, our next speaker from the Department of Geography and Geoinformation Science is Professor Sun, and she's going to tell us about automatic near real-time flood monitoring using NPP, JPSS, VIIRS imagery.
So good afternoon. Thank you for giving me this chance. Actually, this teamwork from the collaboration among GMU, GPS program office, and University of Wisconsin. How to turn pages?
You should be able to just
Right here.
page down. Yeah, it's a little slow, so.
So here's the outline. Why flood? Why we want to study flood? Some principles, challenges, and evaluations. So why study flood? All over the globe, flood is the most frequent natural hazard type. You can see occupy 50% of this pie. Also, with climate change, flood will become more and more frequent because higher warmer temperature, higher water vapor, and so more flood events. Also, in the U.S., flood caused the most deaths, more deaths, and property damage than any other types of severe weather events, like Mississippi River flood in 2011. 392 were killed, economic loss over 2.8 billion. Also, the New York flood due to Hurricane Sandy in 2012, 233 were killed, economic loss over $75 billion. The New York stock market exchange was closed for the first time during more than 100 years. Because of natural hazard. Also, Hurricane Katrina, the total loss over 80 billion, more than 1,000 deaths, as actually most caused by flooding. Background. So, like most of the floods occur over the vegetation or bare soil surface type. Why VIRS? Why we want to use VIRS? If anybody know VIRS, show me NPP and the JPSS. Yes. NPP is the current polar orbiting system between NASA and NOAA. It's the merged project of DMSP and NOAA and NASA. So it's a commercial, not defense and civil polar orbiting satellite merged system. Why we want to use VIRS? Because it can provide wide swaths, 3,000 kilometers without gaps, even at the equator. Also, constant high resolution, like 375-meter resolution for the imagery bands. Also, NOAA's mission is high latitude. Do you know why high latitude? Because over high latitude, conventional observation are very sparse. The high latitude is lack of conventional observation. So satellite observation is proved very useful, very helpful over high latitude region like Alaska. Also, multiple observations in high latitude, like we can get 8 to 9 observations in Alaska. Also, slow melt ice jam flood, satellite data is very effective to identify and monitor this flood type. Hydrology model is usually difficult for slow melt and ice jam flood. Also because this flood type has less cloud contamination than flood caused by heavy rainfall. So our project is initialized by GPS Program Office, and we have developed software, flood detection algorithms, and have been generated near real-time flood products from various imagery. So most of the flood type is like a flood mixed over vegetation or soil type. You can see this from this. I believe most of you are familiar with these spectral features, like vegetation, like represented by these different green colors, and soil, different soil type are represented by these red curves, and dark clean represent clean water. Then light green, or light blue show the turbid water. So you can see clean water. For clean water, the reflectance in the near infrared, like 0.8 or 800 nanometer, and near shortwave infrared, like 1600 nanometer, the reflectance of clean water is almost zero, very low reflectance. So this is why water appeared as a dark color, like gray, dark blue in the first color image. But the reflectance of water may be increased by the suspending water content. So the turbid water usually has a higher reflectance than clean water. But even so, water's reflectance still lower, much lower than the vegetation and the soils in the near infrared and the shortwave infrared. Another flood type is super slow ice. This flood type is our users help us identify or find. We didn't work with this flood type originally. Our users at Alaska and Red River, high latitude region, help us find this super slow ice flood type. Actually, it's water flow from like a Red River, from south to north. But the slow ice was still frozen in the north or in the Red River, Red River. So water overflow cannot move, jammed. Water overflow on the top of slow ice. So it's mixed. This column with water up and slow ice still under. So this is like this. So this type, the reflectance in the visible and the near infrared can be as high as 70% because of slow ice contribution, not clean water. The NDVI values, and I believe most of you should be familiar with the NDVI, vegetation index. The NDVI value for water surface usually is negative value. But for this type, super slow ice type, flood type, the NDVI values from negative 0.6 to negative 0.03. Another way defined a new parameter called dNDVI, or the difference between super slow ice and the average NDVI of surrounding slow ice surface can be very large. So you can see this black represents super slow ice flood type. This ice, slow. So we can easily separate them by using only spectral features. So the biggest challenge for real-time flood detection is cloud shadow, because water has no reflectance. Cloud shadow also has no reflectance. You can see from here. They mix together. Like green is vegetation, red is for water, blue is for bare land, light blue for cloud shadow. They all mix together. So if we only use spectral features, we cannot separate them. We cannot separate the cloud shadow from water. So we developed a geometric method. So by using geometric features between cloud and cloud shadow over the spherical surface, we also use the iteration method to reduce the uncertainty of cloud heights, because we need to use cloud heights, also atmospheric profile information. We found a lot of NASA, even though cloud height products usually exist high bias or uncertainty. So we use this iteration method to reduce this error. So can you see this cloud shadow? So this is the first color image here. And this, if we don't remove cloud shadow, all this cloud shadow will be misclassified as flood, because they share the similar spectral features. So later, we first misclassified the cloud shadow as a flooding water. Later, we use geometry method to separate the cloud shadow from water, so we can identify or remove cloud shadows. So you can remove this force flood. Another biggest challenge is terrain shadow. This is especially true over high latitude region like Alaska, because the terrain shadow also shares similar spectral features as water, like cloud shadow. But terrain shadow usually have it's not smooth. Like the surface roughness for terrain shadow is large. Then the water body, because water body usually have smoothing surface. So we just use this RMS or root mean square of terrain height to remove terrain shadow. Also, we treat whole terrain shadow as an object instead of working with individual pixel. So you can see here's the first color image. Here's you can see the terrain shadow were misclassified as flood. So this is terrible. So after terrain shadow removal, we can separate terrain shadow from flood. So another challenge is the moderate spatial resolution of various imagery. So for small river or water bodies smaller than our resolution, so our product may be limited to detect this minor floods. Also, because of this moderate resolution, so the pixel, the various pixels include water, also land surface type like vegetation, soil, or even slow ice. So it's mixed. So we propose to use flooding water reflection instead of yes or no flooding water to represent this. So now we developed a change detection method to identify minor floods, also developed a dynamic nearest neighboring searching method to retrieve water fraction. We also developed a downscale model to enhance the resolution of various flood map. So this is our downscale model. We can enhance the resolution from 375 to 30 meters. Also, this depends on the resolution of DEM, digital elevation model. Currently we use the SRTM DEM data, so it's 30-meter resolution. Some river forecast centers provided us 3-meter DEM data, so we can do 10-meter, even 3-meter flood map too. So this model used the fluid dynamics or fluid properties of water, because water always flow from high to low. So if you are interested, you can take a look at our paper. So when I reported this work at the AMS, a lot of scientists gave high praise to this work because they think it's a great and significant work. Significantly improved the capability of our environmental satellite, including meteorological satellites. So you can see this is our original flood map at the original 375-meter resolution. This is the enhanced 30-meter flood map along Illinois River. So you can see, can provide more detailed information than the original resolution. Also, this shows the first color image. This is the flood map at the original 375-meter resolution. This enhanced 30-meter resolution flood map. You can see this high-resolution flood map can help river forecasters to investigate or monitor the flood status and the risks of levees, because these river forecast centers and also levee, they care about individual levee and the rivers, so they need a very high-resolution flood map. Also, this high-resolution flood map can even provide the detailed information about a levee, such as a bridge. But this cannot do it. Original resolution cannot do it. So bridge, so levee, like FEMA levee, they need a high-resolution flood map. Their hydrology model, just for 1 kilometer resolution. So this is the flow chart. We first needed to identify cloud, get cloud cover, then slow ice mask, slow ice cover, then normal flood type, super slow ice flood type, then remote cloud shadow, terrain shadow, then use change detection method to identify minor flood, then retrieve water fraction, and then get a flood inundation map, like two types, super slow ice flood and normal flood. So this shows some, these are real-time flood products can be available. Let's see. This doesn't work. This link. So I can show you. So currently we provide operational flood product to 5 river forecast centers like here. So this over the real Earth or Google Earth can also be available at an AWAVE system or National Weather Forecast, National NWS weather forecast system. You can see we can zoom in, zoom out, and more back and forth. So we can also, another unique function I like very much is the you can change the transparency. So if you know the transparency, you can get the GIS map. So very clear where is the flood, where is the flood located, where is the river, where is the flood. So you can even zoom it in very high resolution, like here. So you can see the individual flood, normal water. So I here show an example because this is a very complicated situation. Like here's the left show the fourth color image, or the right show our flood map. So you can see the slow ice. Slow is represented white, cloud is light gray, then shadow is dark gray, and the overflow or super slow ice flood type in purple, then ice, including river and land ice as light blue, then blue as normal water, then flooding water fraction in the from green to yellow to red. So we did some evaluations against the ground observations, like river gauge observations. You can see our flood type can provide spatially continuous flood distribution instead of point observations for river gauges. Also, we can provide flood information over land, not just river. So actually, you can see they agree each other very well. Another is we compare with NOAA flood outlook products, flood warning products. You can see because their resolution is 1 kilometer, they use a hydrology model. So our product can provide higher resolution than these products, so can provide more detail, also can find, can identify more, like this red circle, can identify more flood information not covered by the hydrology model. So next summary, we have solved the critical issues like cloud shadow and terrain shadow, make the real-time flood products become possible. Also, we developed the inundation model or downscale model, so can enhance the capability of moderate to coarse resolution sensors, like most environmental satellites and including meteorology satellites, because they have high temperature resolution, wide coverage, but their coarse or moderate resolution may limit their wide applications. So we can enhance their capability. Also, with our inundation model can enable us to generate three-dimensional flood products, including flooding water surface level, flood water depth, also high-resolution flood maps. So these are reference. Any questions? Thank you. Thank you.
The model consider like dams or bridges, those structures along the river.
We don't include that much detail dam. We just like water, identify water. We don't work with like engineering part, like dam structure or bridge. No, so any other questions? Thank you.
Thank you. That's what you're saying. Okay, our next speaker is Dr. Halder. He's faculty in atmospheric, ocean, and earth sciences, and he's going to tell us about the impact of soil moisture variability on the Indian monsoon.
Thank you. Good afternoon, everyone. So I am a postdoc working with Professor Paul Jarmeyer and Professor Kinter, James Kinter, and Dr. and Marx is also one person in our group with whom we have worked. So moving from water to soil moisture, which is the key element in the ground that impacts surface fluxes and near-surface atmospheric variables, and the near-surface humidity, temperature, and for moist convection and chances of triggering. And we are working in a collaborative project with the Ministry of Earth Sciences, Government of India. So I'll be talking about the impact of soil moisture variability on the Indian summer monsoon. So this is the brief outline. So I'll be talking about the motivation for the study at first, and then give you some idea about the theory of land-atmosphere coupling, the modern land-atmosphere coupling paradigm that we follow in our research, and then tell you about two stories. So how remote soil moisture variability affects the variability of the monsoon on the monthly time scale, and then also how local soil moisture variability can affect the variability, and then followed by conclusions. So this is a time series of the yearly time series of precipitation from 1871 to 2005 over the Indian region. It shows that the Indian summer monsoon is characterized by internal variability, which is about 10% of the long-term mean, and there is also significant variability on the subseasonal time scale, which are known as epochs of above and below normal rainfall activity, or active and break events. Now, this variability is governed by slowly varying boundary conditions like sea surface temperature, snow cover, soil moisture, and then there is also intraseasonal variability, which is affected by mid-latitude weather, and then there is West Pacific storm tracks, and soil moisture variations can also contribute to the intraseasonal variability. And most importantly, about 50% of the internal variability is controlled by internal dynamics, which is chaotic dynamics because of the land-ocean atmosphere coupled system. So all these things make the accurate prediction of the Indian summer monsoon rainfall a really challenging task. And then we are trying to find out how soil moisture initialization and representation of coupled feedbacks affect the simulation of the variability in the state-of-the-art models and the prediction skill. So the modern land-atmosphere coupling paradigm says that there needs to be three components for the land-atmosphere coupling to be strong and soil moisture to significantly affect near-surface variables and convection and temperature, etc. The first is coupling, and there is sensitivity. That means there has to be strong covariance between the soil moisture and surface fluxes. And then there has to be sensitivity. That means the surface fluxes variations has to be very sensitive to changes in the soil moisture. Then there has to be variability. So unless the forcing term varies sufficiently, then it will not affect the surface fluxes and near surface atmospheric variables. And then thirdly, the forcing anomaly has to persist for a long time. That means there has to be soil moisture memory for the forcing to persist for a significant amount of time, and for the surface variations to translate into variations into the near surface atmospheric variables, precipitation and temperature. So other than that, we need good models and better initial conditions also. So how does the land-atmosphere coupling work? So basically there is a two-legged hypothesis that we follow. So there is the terrestrial leg, which determines how soil moisture variations affect surface fluxes. So this is called the terrestrial leg. And then there's the atmospheric leg. So that means the surface fluxes of latent heat and sensible heat, how they affect the evolution of the boundary layer, near surface humidity, and how does the boundary layer grow into the level of lifting condensation, and there is moist convection, formation of clouds, and whether that impacts chances of precipitation formation or not. So this is the two-legged hypothesis. So let us try to understand how does the terrestrial leg work. So the terrestrial leg of the land-atmosphere coupling basically speaks about the correlation between the moisture and surface fluxes, soil moisture and surface fluxes. So this is a scatter plot between observed latent heat flux and soil moisture over a certain region. So you can see over the dry region where it is below the wilting point for that particular surface, when soil moisture is very low, little changes in soil moisture don't make big changes in the surface evaporation because it is already very low. Whereas when we move towards the saturation level, so although the surface is very saturated, then soil moisture variations don't make big impact on the surface evaporation, because it is the availability of net radiation that controls the variability of the fluxes. Between these two regions, which is called the transitional regime, is the region where there is maximum sensitivity of surface fluxes of moisture and heat with respect to soil moisture changes. So if you plot a straight line, a best fit linear regression, so the slope of this linear regression will give you the sensitivity. So the change in fluxes per unit change in soil moisture. So there were classical studies in the recent past that have shown that these are the global hotspots of land-atmosphere coupling. What is meant by hotspots? So modeling studies and observational studies have shown that there is strong correlation and covariance between the soil moisture variations and surface moisture fluxes over these regions. So these are the tropics, this is over the US, central US, and this is over the central and northwestern part of India. So these studies suggested that if the soil moisture states are correctly prescribed, or the models, global forecast models, are accurately initialized over these regions with accurate soil moisture, then they should have a strong impact on the prediction and the prediction scale of temperature and precipitation over these regions. Now, the Indian monsoon region happens to be one of those global hotspots, and this gives us confidence that we need to do further research to understand the impact. So there is another study that showed that there can be also snow atmosphere coupling. During the transition time from winter to spring, when there is no melt, so the hydrological effects can contribute to significant snow atmosphere coupling for temperature and precipitation. And they showed that during the snow melt, the coupling strength is maximum. So how does remote soil moisture affect Indian summer monsoon? So this was a study done by Professor Shukla and Banzai, who were faculty here a long time ago. They showed that the albedo effect, so during winter and during spring, so this is DJFM and this is April-May, so the snow cover and the snow depth, they have inverse correlation with the all India summer monsoon rainfall. But they mainly focused on the albedo effect of snow. They didn't focus on the hydrological aspect. And there is also long-term internal variability in the snow-monsoon relationship. So we focused on the hydrological aspect of the snow cover and snow melt. So what I show here is the mean snow cover fraction and the internal standard deviation, and the mean snow water equivalent and internal standard deviation. So this is December, January, February, March, and April, May. So this is basically winter. This is basically the transitional period when the winter is transitioning into spring and it's melting. So what you can see here, that there is permanent snow cover mainly during winter over the northern regions of the Eurasia, and there is more variability towards the southern stretches, and as the sun moves northward, there is more melting. So associated with that, the variability also starts increasing. So how does this variability impact the atmosphere? So this is a plot of the mean annual cycle of the western Eurasia and the eastern Eurasia. So this is for snow cover fraction. This is snow cover fraction, and this is snow water equivalent over western and eastern Eurasia. This is surface soil moisture. This is layered root zone soil moisture. So what you can see that its snow cover starts melting around March, April, and May, and then as it starts melting, then surface soil moisture also decreases very rapidly. So once the peak soil moisture decreases below the mean value, then it's, we can expect that it will lose its memory very soon. Compared to that, although the mean snow water equivalent of the soil moisture over the eastern region is low, but once it starts melting, the anomalies persist for much longer time. So we expected that persistence should impact the soil moisture memory, and there we can explore how that persistence translate into near surface atmospheric variables also. So what we did, we made a time series of all India rainfall and then made composites of above 1 below normal rainfall during the first 30 days after onset and first 60 days after onset, and found out which are the years when the rainfall is below normal, so that is below 1 standard deviation, and which are the years it is above 1 standard deviation. And we made a composite and subtracted the snow cover fraction and the snow water equivalent from the below normal years from the above normal years. So what we see that when there is below normal rainfall over India after onset, whether it is 30 day or 60 day, so we can see the snow cover fraction anomaly is positive over the western part, and the soil moisture anomalies are negative over the eastern box. So snow cover fraction anomalies are positive. This has already been studied, investigated in previous literature. So there was nothing new about this. But what was interesting that although the snow cover fraction appears to be more, it's very thin. So snow water equivalent is basically the hydrologic potential of the snow cover fraction. So negative anomalies show that it is very thin. So that means it will melt very soon. And it was interesting to find that there was negative anomalies over this region. This is a very arid region over the part of Mongolia, northern China, and the southern parts of Russia. So this was interesting for us. Then we looked at differences in other variables. So this is difference in surface soil moisture. This is from GLDAS. This is 2-meter temperature, and this is 500 hectopascal geopotential height, and this is tropospheric temperature. So what we see that below normal snow water equivalent is associated with also, negative anomalies in soil moisture. So that means there is more warming at the surface, and it is evident in the tropospheric temperature anomalies. So the tropospheric temperature is warm, and there are positive anomalies in geopotential height. So that means there is the effects are seen not only at the surface but also in the deep troposphere. So something associated with the surface is also going on in the atmosphere. So what is happening? So now what we did, we made a time series of soil moisture over these eastern Eurasian box, and then found out above and below normal years based on those soil moisture. And then we composited circulation anomalies based on that. So this is the 200 hectopascal circulation in April, May. This is June and July. And this is the difference. So below normal years minus above normal years. So what is the climatological feature is that we have the subtropical westerly jet. So during the onset of the monsoon, the subtropical westerly jet should move beyond 30 and 35 degree north. If not, that means the onset is late or it is weak. So differences shows that because whenever there are negative soil moisture anomalies, there is a ridge, anomalous ridge also in the upper troposphere associated with the warming and the positive geopotential height anomalies, and troughs in the westerlies, they penetrate deep into the monsoon regions, which bring in cold and dry air into the region. That decreases the convective instability, and that decreases the rainfall. So this is a dynamical mechanism through which the soil moisture anomalies over the Eastern Eurasian region and the rainfall over the Indian region are connected. Now one might question that the soil moisture anomalies are very less over the Eastern Eurasian region. Does it matter for the atmosphere? So here we plotted the sensitivity. So sensitivity is slope of the curve between sensible heat flux and soil moisture, latent heat flux and soil moisture, and PVL height. So here the blue one is for the Eastern Eurasia, red is for Western Eurasia. So you can see the sensitivity of the fluxes per unit change in soil moisture is more over the Eastern Eurasian region. That is why even though the soil moisture variations are less, the atmosphere is able to feel the variations in surface fluxes, and that is why there is stronger land atmosphere coupling over the Eastern Eurasian region. Furthermore, we see that the mean soil moisture memory is also longer over the Eastern Eurasia. So that means we can have some persistence based on the Eastern Eurasian soil moisture anomalies, and it is able to describe whether the rainfall anomalies are going to be above or below normal post the onset. So now, what is the effect? So this is what happened over the remote region. So what happens due to local soil moisture anomalies? So to understand that, we made an ensemble of simulations with the NCEP, NOAA, coupled climate forecast system model, which is the operational forecast model of the National Weather Service. So what we did, we had 28 years of simulation. For each year, we had 3 sets of runs starting in April, May, and June, and ending up till the end of September. And for each atmospheric and ocean initial condition, we plotted the land initial condition. So we had 28 different land initial conditions pertaining to 28 different years. So these are the results. So this is how the mean monthly and seasonal precipitation look like. This is June, July, August, and September, and JJS. This is the interannual standard deviation. This is observation, and this is the bias. So you can see the model shows there is dry bias over the land and there is a wet bias over the ocean. So we try to understand that what is the cause of this bias? How does land atmosphere feedbacks and land surface initialization affect the forecast bias? So I mainly focus on the land atmosphere coupling paradigm that I described in the beginning. So here is the soil moisture variability, daily soil moisture variability for the surface and the root zone. So in the NOAA land surface model that is used in this operational model, the surface is 10 centimeter thick, and the subsurface root zone is 30 centimeters thick. So that is 10 to 40 centimeter. So we can see that the soil moisture variability is mainly strong over the parts of the central Indian region, and it's mainly high over during the months of June and July. And then as the monsoon rain bands progress from west to southwest to northeast, southeast to northwest, so the soil moisture, the surface saturates, and then the variability also decreases. And there is more variability in the surface soil moisture because the surface is exposed to the atmospheric processes. So there is relatively less variability in the bottom layers. So this is the land atmosphere coupling strength for near surface humidity and precipitation. So this is the terrestrial part of the coupling, and this is the atmospheric part of coupling for near surface humidity. This is the atmospheric part of coupling for precipitation. So the terrestrial part shows the covariance between soil moisture and latent heat flux, and the atmospheric part shows the covariance, product of the correlation and the standard deviation of the forcing variable. So this is between latent heat flux and near surface humidity, and this is latent heat flux and precipitation. So what you see is that so when both the terrestrial and the atmospheric segments of coupling are strong over a particular region, we say that the land atmosphere coupling for that particular variable is strong and is in place in that region. So you can see that the land atmosphere coupling is strong in the months of June and also in the July. But as the monsoon progresses, the land surface becomes wet. It becomes more wet and humid, so the soil moisture variability also decreases, and you can see that the coupling strength decreases. So we thought we'll focus mainly on the first 2 months, try to understand the processes, because the onset, in observations, the onset of the monsoon takes place from the beginning of July till beginning of June till mid of July. So here is a picture. This shows that when the model is initialized in April instead of June, then how does the land atmosphere coupling changes? So this is a difference in the coupling for the terrestrial and the atmospheric components, April minus June. You can see that the coupling strength decreases for both the components, for near surface humidity and precipitation. So as the model evolves from April, it tries to move away from the nature. So it is initialized on the 1st of April, and then it tries to, when it runs freely, it tries to evolve to its own climatological state. So the biases also evolve, and the land atmosphere coupled feedbacks, they move, they also, if there are biases in the representation of the feedbacks, then that will affect the coupling strength. So you can see that the coupling strength decreases with the forecast lead time. Second is the sensitivity, which is another component. So this is the mean sensitivity in the first 15 days of June. This is in the second 15 days of June. By sensitivity, I mean the slope of the best fit linear regression between latent heat flux and soil moisture. So change in latent heat flux per unit soil wetness index. You can see that there is a lot of sensitivity in the beginning month, in the months of June, but when the model is initialized in April, you can see that the sensitivity decreases for the first and the second halves. So that means, so the sensitivity decreases, the coupling strength decreases, and then third component is the soil moisture memory. So this is the mean memory in June in days. So this is the layer 1, layer 2, layer 3, which is 60 centimeter, and the layer 4, which is the bottommost layer, is 1 meter. So this is the memory in July, and this is the difference of the memory when it is initialized in April. You can see the mean memory is very low, less than 1 week over most of the land part for the surface. Because in June, once it starts raining from the eastern side, so as the soil moisture rises, and then it loses the initial memory of the initial state, which was there on the 1st of June. The mean memory is less here. It is more over the arid region and over the hotspot, the classical hotspot region. And then as we go down, the memory increases. So there is more soil moisture memory in the bottom layers. As we move into July, we can see the memory is further less. It may not be quite visible here, but it's less than what it was in June. So, and then when the model is initialized in April, so the model is also drying out. So the coupled biases evolve with time. So as it dries out, so you can see that the memory in April is more than it is in June. So what happens? So this is a difference in the precipitation on the left column, temperature and soil moisture between April runs and June runs. So you can see, so because of the biases in the coupled feedbacks and the initial conditions and the soil moisture memory, you can see that the biases, the precipitation biases also increase, and also leads to biases in temperature and soil moisture. So we have also looked at the impact of the initial conditions, what's the impact on the forecast skill, but we cannot discuss everything here due to shortage of time. But so I tried to give you a short summary of how remote soil moisture variability and local soil moisture variability and feedbacks affect the variability of the monsoon on the monthly time scale, and also it affects the skill. So conclusions in brief. So we need to have accurate representation of snow atmosphere coupling in the state-of-the-art climate models, and then we also need to have accurate initialization of snow and soil moisture and land atmosphere coupling for better simulation of variability of the monsoon, a complex system like the monsoon, and also for better prediction of the monsoon rainfall on different time scales. Thank you. Thank you for listening.
Any questions, Dr. Palmer? We are now scheduled for a break till 3 o'clock. We'll pick it up again right at 3. We have some very interactive sessions left for the rest of the day, so I hope to see you back. I believe we have some snacks out there. If you didn't get lunch, there's probably an extra one up there, so help yourself in 162. And if you're presenting this afternoon and you haven't loaded your session up here, let's do that over the break. Charlie, hi.
Charlie, hi.
Nice to meet you.
Good to meet you.
Okay, so let's see. If you plug it in down here, this one seems to work better. The one on the side of the monitor wasn't playing well with others earlier, so. Okay, good, it's loading. I'm sure I'm getting some love. Everybody's favorite when you go to present, so. Thumb drive doesn't come up.
So I've got PowerPoint or PDF. Which one do you think?
Whatever you want. If you just want to.
I'll just put it on the base desktop. Yeah.
That's good.
Like that. And I'll bring the other one down too, just as a backup. It's belt and suspenders. That's what it is. Sometimes the colors and stuff get screwed up with different versions of PowerPoint. So.
Usually, when I do this here,
That, you know, was really amazing, but if you look at the history of like the legs, there's maybe one time like in the past, but it's still like, you're making my
Don't ever let him get away.
I think well, we can try plugging it in up here this time. It didn't work earlier, but we can plug it in. If it doesn't work, we'll plug it in down below. But
And it should really be it should be the only PowerPoint on this thing. So.
okay.
Okay. I don't think that's it. Yeah. Oh, really? I don't think that's not. That's not mine. Mine didn't come up. I can always pull it up, I guess, on Google. Oh, true.
you able to rotate him into speaking? What's that? Are you able to rotate him into speaking? Is he judging? Oh, he's judging. You guys heard me going, yeah, a slight change in schedule. Last week was sick because we're judging posters, so we're going to start 20 after 3 instead of 3 o'clock, and it's already we have some oranges.
I am coming back. No, 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 I can't. The class is, it's Oscar, so you have to just one. Yeah. Okay. Okay.
We're going to get started with the afternoon sessions, and some of you guys are such troopers. We had a couple of people at the last minute who got sick or couldn't come, and we had other people fill in, and we had our very last speaker who was sick, but their boss and another person came all the way from Leetown, West Virginia to present because they didn't want to let us down. So now that I've moved it back a bit, we have an extra presentation at the end, but it's all good. It's all good. So let's see. Charlie, yours is the PDF, right? Okay. For the afternoon session, we have Charlie Bergwat, who's a graduate student in geography and geoinformation science, and he's going to present on text mining archive NOAA weather bulletin.
So, as it says there, I'm a PhD candidate, which means I've got all my classes done. Now I've got to do my dissertation. And so what I'm going to talk about is kind of the front end of the dissertation. This is my dissertation priorities right here. Get data, get data, get data. You know, it sounds like the real estate phrase, you know, location, location, location. But, you know, it's really what I'm after. I'm into remote sensing. And, you know, we've got all these satellites covering the Earth 24 hours a day. And if you want to find something, you got to know where to look. So that's kind of what the first part of my research is all about. And that's what the text mining is all about. My topic is tropical waves. And I got interested in this with when I was in a class with Dr. Hauser about 3 years ago. And I wanted to look at, see if there's anything in a tropical wave that had something to do with Hurricane Sandy. That seemed to be the thing that I was interested in. And I didn't know what tropical waves were at the time, but I did some studying, and so I kind of got it figured out. So what I want to do is find tropical waves over a number of years and look for trends, changes in year to year in the way the tropical waves act or how frequently they occur. And you can see here a tropical wave is just basically it's a weather pattern over the Atlantic Ocean. And there's a cloudy area, there's precipitation, there's a lot of moisture. That's the connection with water, I guess. It's in the atmosphere. And in the GOES image over here on the left, you can see I marked a couple of cloud patterns, and that was my attempt to identify tropical waves. And I learned at that point that tropical waves, you can't just look at the cloudiness. You really have to know more about it. And I kind of figured, well, I'm a little out of my league. Maybe I should depend on somebody, a professional, like the National Hurricane Center, to identify tropical waves. And so that's what I did. This is kind of the flow of activities of my dissertation project. The first one is to get the tropical wave coordinates. And so I've collected 11 years worth of tropical wave coordinates, and I'll show you how I did that. It's a major thing that I'm going to be talking about. But then I also built tracks. Just like a hurricane track, you can track tropical waves. Where is the center of the tropical wave? Where's the center of this weather system at any point in time? And because the National Hurricane Center often reports more than one tropical wave at a time, it's kind of hard to keep them separate. You got to be able to connect the same tropical wave together day after day. And so that's what the tracking was about. And then finally, there's the analysis section, and that's where I go out and I get data from satellite data from a website, and then do my analysis. And I'm in the middle of that now. The satellite data that I'm using is from the air sensor. It's the atmospheric infrared sounder. And this is on the Aqua satellite. It's a NASA satellite. And it collects data every 6 minutes. It's sounder data, so you get a temperature profile of the atmosphere from space all the way pretty much to the surface. And you also get moisture. They have data products that give you moisture, temperature, pressure, geopotential height, basically. And then they have other products like cloudiness, cloudiness at various levels, and cloud phase, ice crystals versus liquid water. So there's a lot of information from the air sensor. And this has been flying since 2002. So I have data from coordinates. I have 11 years worth of coordinates and 11 years worth of satellite data, and I know where to look. So I feel like I'm in pretty good shape. Now I just got to know what to do with all this information. So this is where I did the text mining. This is an example of a tropical weather discussion. I get those terms mixed up. But this is a weather report or a weather bulletin that NOAA puts out every 6 hours. And they've been putting these out since, online, the furthest back I can go is 2003. This particular document or bulletin is from October 2012. And you can see that it's the areas that it's covering. It's the tropical Atlantic from Africa to the Caribbean Sea. And then from the equator up to about 32 degrees north latitude. And their analysis is based on, says here, satellite imagery, weather observations, radar, and meteorological analysis. So this comes out every 6 hours. And what I'm going to do is show you an example of the text mining I did. Now this document, I found out since I first started doing this was really designed in a way to make text mining easy, which is great. And so you can see that as you look through the text of this bulletin, there is a section called Tropical Waves with 3 dots in front of it and 3 after it. Now, that's pretty unique. So if you've got software that can parse through this text file, and you see that as you're going through it, you know that what follows is going to be about tropical waves. And also in that first sentence, you can see that a tropical wave is a long and then some numbers. And so you can also parse through these text documents with some software to find the word tropical wave or tropical wave is, and then you've got your coordinates. And so here they've put down 32W/33W, so that's longitude, west longitude. And then later on in the sentence, you can see a 15 followed by an N. And so I wrote software. I used Visual Basic, which is free in Excel. Well, maybe it's not free with Excel, but it comes with Excel. And so that was the perfect setup. That was Visual Basic worked just fine for this kind of text mining. It's pretty simple. So I was able to just parse through all these documents. Remember, there's one every 6 hours for 11 years. That's a lot of documents. But it goes through, and I think it's, I've worked on it for quite a bit to try to get it to be the highest percentage I could of success. And I'm to the point now where I can't find any errors. But I don't know, there's so many documents, I don't know if I've got an error or not. But at least I'm getting a lot of good data, a good sample anyway. So they're looking at 2 tropical waves. These are both in the same report. The top one is at 32 degrees west, and then in the second paragraph, there's another one at 43 degrees west. So you can see we have 2 tropical waves being reported at the same time. So I have to be able to keep those straight as they progress day after day across the Atlantic. Okay, now this is screenshot of my an Excel spreadsheet, and I don't expect you to read it. It's pretty small print, but that center row is those two paragraphs just kind of compressed together. And so I'm going to parse my my text in here. Now I pulled that text out of the tropical weather discussion based on that header that said ... tropical waves ... So that identified the following information until I got to the next section, which was something else with dots in front of it. And in the left-hand column is a file name. I've given all my files, all these text files, a name that's unique. It has a date, a time and date embedded in the file name, and that's for 2012, October 15th, 1800 hours and 2 minutes, Universal Coordinated Time, Zulu time. So that was kind of the first step, was to get that kind of taken out. Then what I did is I zoomed in and took care of those sentences. And now we've got a lot more data here. But you can see 1802 in that second to the left column. That's the two tropical waves that we were just looking at. And so now we've got a much shorter phrase. And again, this is just another iteration of the software working a little bit deeper into the text. And it's seeing the word, it picked out the word tropical wave is along, I'm just comparing strings, and I've actually got that in the software. A number of examples, a number of things to look for. And so it says tropical wave is along, and then you can see the 32W. So as I parse through that sentence, I see a number, 32, followed by a W, or it could be an E, but it's usually a W for west longitude. And then and I record that. And you can see in the over here, in this column right here, LON for longitude, there's a minus 32. And then there's also a 15 in this first column. So that's the latitude, which was farther along in the sentence. And then the next, in the same report, there was a second tropical wave, also at 1802, and I was able to pull out the latitude and longitude there, 19 degrees latitude and 43 degrees longitude. Now, there's more than just two columns. A lot of these reports will include the location at the top of the tropical wave and the bottom of the tropical wave. If you remember back in this graphic, you can see they have an axis, these lines, these vertical lines. So they'll always report the top end of that, the north end of that, but sometimes they report the southern end of it as well. So at this point, now I've got my coordinates, and I'm ready to go. I've got spreadsheets. I've got a separate spreadsheet for every year. I got 11 of those. So there's thousands of these tropical wave observations. Now what do I do? Well, this is all the observations for 2012, all those green dots. Every one of those is an observation. And of course, there's going to be more than one observation on a lot of these points. But with just the point data, there's a few things you can do. You can kind of think about, you can kind of see concentration. You can see, well, the tropical waves tend to be sort of north of the equator, but not too far north, and they certainly start in Africa and kind of end in the Caribbean. And there's things you can count, that kind of stuff. But in the middle of this, you can see there's a red line, and that's a single track of one tropical wave. And I've got probably a couple hundred of these for every year. And the tracking is a separate talk altogether, but that was software that I got off it's open source software that I modified for my use. Let's see. Now, so this is text mining. This is what you can. The reason why I had to do text mining is because there's no database that I could find that had tropical wave locations in it. There's a hurricane database called the HURDAT, or HERDAT 2. I guess they modified it and have version 2. And I've looked in that database. This is probably something that NOAA takes care of. And they do talk about tropical waves very rarely. And it's usually a tropical wave, turns into a tropical storm and then into a hurricane. So I think in people doing research, to try to make your research unique, if the data is unique, if the data is data that you have that nobody else has, that makes your research unique. And one way to get unique data is to do text mining. And so, you can search news articles for, because we're in the water here, you can search for things like flood, drought, and pollution and find articles or phrases that have those words in them. If you need location, there's software out there that's easy to get that where you can detect place names, like Koza City, Okinawa, for example. Where's that, right? And then you can use geonames to get the coordinates. You can type in some obscure city name and the coordinates will come out. These are software capabilities that are out there. They're free to use, and that's something you might want to try. And then date and time is usually included in a news article somewhere, maybe in the metadata. Now, this is a lot of work. There's a lot of things going on in the world of geography that has to do with stuff like volunteer geographic information, being able to get information from different sources, And Michael Goodchild, professor out in Santa Barbara, has talked about something called ambient geographic information. And this is the sense that geographic information is kind of all around us. All you have to do is figure out how to pick it out, how to go get it. And that's what text mining is being able to go into news articles and other kinds of information to get geographic information about an event or some sort of meteorological process or something, and then get the latitude, longitude, and a timestamp. So there's some text mining ideas if you're interested in using that. And that's all I have. This is my contact information. If you want to talk about text mining or anything else, there's my phone number and my George Mason email. Okay?
Time for a question or two while we get the next presentation up. Okay, well, let's see, our next presenter. My Excel work looks lightweight compared to yours, so makes me feel better. Okay, our next presenters are Christine Fegan and Taylor Pessine, and they're going to talk about the WASH project, providing access to clean water in the Peruvian Amazon. And is it?
It's that one right there. This one? Yeah. Perfect. Great. Thank you.
Thank you.
I think I can project. All right. Hi, everyone. I'm Christine Feigen. I'm a senior here at George Mason, and I'm the co-project manager of the Amazon WASH project, the Amazon Water Sanitation and Hygiene Project. We are a student-run organization.
And I am Taylor Pessine. I am also a senior, majoring in applied global conservation. And our faculty advisor is Dr. Mike Gilmore, who couldn't be here today because he's taking care of business in the Peruvian Amazon with the Maihuna people, who we'll talk a lot about during this presentation.
All right. The World Health Organization and many other who are familiar with this field understand that water is a global issue. And unfortunately, it affects many of the world's developing nations. As you can see here, some statistics we found, 3.4 million people die each year from water, sanitation, and hygiene-related causes, and 99% of those are in developing nations. And these statistics are really what our group is focused on changing.
So, like I had mentioned before, the Mahuna people is the group of people that we're concentrating on right now, and they're an indigenous group located in the Peruvian Amazon. They have approximately 450 individuals in the community, and there are 4 separate communities. They speak a native language called Mahinki, and many of them also speak Spanish. And Christine and I had the chance to go to the Mahuna lands last summer, and we both got our Mahuna names, which was really exciting. And but we also got to see how they carried out their daily lives. We saw that they relied heavily on hunting, fishing, gathering, and farming. As you can see in this picture, it might be a little small, but the houses are on stilts, and they're located right next to the river. So during the raining season, a lot of the times the river floods, and to protect them from their houses, they have their houses on stilts. But the water is a major resource for them.
So where in the world are the Mahuna? This is a map of Peru. The Mahuna communities are located just north of the city of Iquitos. There are 4 communities, as you can see in this map over here. They're pretty well spread out. Peru is home to the 2nd largest portion of the Amazon rainforest. And fun fact that Iquitos is the only city that you can't drive to. You have to only get there by airplane or by boat. So also with the villages, in order to be able to access these villages, you have to go by boat.
Okay, so in these 2 pictures, this is the pictures of the rivers that are located right next to the Mahuna, and the ones that they utilize quite often. They utilize them for drinking, cooking, cleaning, and also cleaning of animals after hunting, bathing and defecating. And on earlier trips, we had found that the communities lacked knowledge in sanitation and proper practices of sanitation and hygiene. And because of this, it has led to high infant mortality due to widespread waterborne illnesses like dysentery.
So our group, like I mentioned earlier, is mainly focused on improving the lives of the Mahuna. So Dr. Gilmore has worked with the Mahuna people since 1999. So they came to him and asked him for help on improving their quality of life. So we sent a group down to the Mahuna people, and we observed their ways of life. And I think the thing that we really realized was that they really needed help with access to clean water, and they needed education on sanitation and hygiene. So right now we're working on that phase. We've been to 3 villages, and we'll talk a little bit about that later. We've installed water filters and taught lessons to each of the households there. And we have plans for future projects that include building latrines, but the access to clean water had to be taken care of first.
So in part of achieving our goal, our team focused on a community-based approach. It was really important for us and the Mahuna that everyone be really involved in this project. So in order to do that, we held town hall meetings when we arrived to the Mahuna lands to talk about the project, explain our goals, and also get the feedback from the community. During the water filter building, we made sure that the community members knew how to build the filters. We wanted them to build them with their own 2 hands, to take ownership of the filters so that they would use them consistently. And we also had volunteers from the Mahuna community to be community health promoters, and they served as leaders in the community. If anyone had questions about the filters or the hygiene lessons, then they could go to those in the community and ask them.
Yeah, and this is one of my favorite pictures. I took this picture when this was a community health promoter that was working with my group. So he watched us teach these lessons in each household for about 4 days. And on the 5th day, it was the last day in that community. and he was able to teach the lesson to that family. And I think it's a really good representation of how they not only understand what we're teaching, but they'll be able to pass it on. So when we leave, they're self-sustainable. Okay, so I mentioned biosands water filters. These are what we built in each household. I can explain it a little bit here. So basically, this is PVC pipe found at a local, hardware store. We used repurposed olive barrels. They're about that wide and about that tall. I think we have, there's a picture of one there. This is a layer of large stones, followed by a layer of smaller stones, followed by a large layer of sand. And the idea is that as the water slowly drips through this barrel, not only will the physical pieces that you can see, that those will be removed, but there's a biolayer that forms on top of the sand. So as the water flows through it, there's a layer taking out most of that bad bacteria that's causing the dysentery.
So in addition to the biosand filters, we also had hygiene and sanitation lessons that we mentioned earlier. And it was really important to make these lessons interactive and engaging. So, for example, when we were talking about germ theory and how germs spread, we used lotion and glitter. The glitter was representing the germs. So we had one of the volunteers put on lotion, and we put some glitter in their hand and rub it all around. And we would practice the spreading of germs by shaking hands and touching the filters so they could see, because you can't see your germs, obviously. So when you're putting your hand on the filter and things like that, you could see the glitter transfer. So really fun interactive things. For brushing teeth and talking about germs in your mouth and preventing health issues that way, we used those purple tablets. A lot of times they do that in elementary school. You switch the purple tablet around and your mouth is bright purple, showing all of your germs. It can be a little embarrassing, and oftentimes some of the Maihuna were a little shy, so I was usually the one who had the purple mouth, and they were all laughing at me. But it was a really fun way to interact with them and teach them.
Okay, so I mentioned we've been to 3 out of the 4 villages. In 2013, a team of ours went down to Sukasari, which is the bottom village. It's closest to Akito, so it's the easiest to access. There we built 28 filters and conducted 28 lessons. And then this past May, Taylor and I were part of the team that went to the villages of Nueva Vida and Portuaman. And there, between the 2 villages, we built 35 filters and conducted 35 lessons. So far, we're at 63 filters, 63 lessons. We mentioned earlier there's about 450 of the community. So we're getting close to getting access to clean water for everyone.
So after we implemented the filter and we're done with that trip, we had an additional trip that was called our assessment trips. Dr. Mike Gilmore would go back to the Maihuna lands and check on the filters and also get a health update. Most families did implement some of the hygiene and sanitation lessons, and families expressed less dysentery and improved overall feeling of health.
So right now we have the last village to get to. It's Totoya. It's the most remote, isolated villages, so clearly we saved the best for last because it's a very long boat ride and then about a 10-hour hike to access the community. So it will be a little bit more challenging than our other communities, but we have a pretty solid plan in place. And as long as fundraising goes according to plan, we should be able to reach this community this summer.
And Totoya has 25 households, so we'll be building 25 filters. And we are currently fundraising. We've had a bunch of different fundraisers this semester, and we're writing grants right now. And we're currently halfway to our goal, so we're all really excited.
So Taylor and I, we feel incredibly lucky to have experienced the Maihuna firsthand. We really feel like this project has had an impact on their lives. And one interesting point, the UN has outlined clean water and sanitation as one of their sustainable development goals. It's the new version of the Millennium Development Goals. So they hope to accomplish this by 2030. So to wipe out, well, I guess, provide access to clean water and sanitation across the world, because it is such a pressing issue. And our hope that is with projects like this one that we'll be able to make this goal a reality. So this is our website. There's a URL code to our website. That's all we have for you. Questions? Yeah. I think the idea is to go in August. Since we don't have all of the funding yet, we don't have all of the plans made because you have to put payments and things down for, and mostly the boats is like the big issue for when we can get the boats to go.
So, generally, how long would the filter last?
That's a good question. Okay, so I should have mentioned this earlier. Our filters were designed by 2 engineers. They're Mason alumni, so we feel pretty confident that they're well designed. They are supposed to last for 30 years. So the idea behind when we built these filters were that it wouldn't be a filter that we put in and 2 years later we'd have to go back. It's not very sustainable. Now we don't have hard data because these filters have only been, let's see, Sukasari, so 3 years or so. The filters were built off of a lot of research on biosands filters. They've been installed in other places in the world. So their idea is that they should be able to keep them for 30 years. We taught the Maihuna sustainable techniques on how to clean it. You do have to clean out the biolayer and just ways to upkeep. So if a handle breaks off, they can buy a new part of the PVC pipe and put it back together.
There are a lot of hardware stores right by.
No. Not at all. They have access to Iquitos by boat. So I guess when we traveled back, a few people jumped on our boat just to get a free ride to the city. So yeah, that's a tough one. But they do have access, just not right by.
So has somebody, they have tested these for microbial removal, bacteria in particular?
Yeah, so the first assessment trip, they took water quality standards down, like testing. I wasn't there for that. But I can say that I drank from one of the filters, and I didn't get sick, and I have a pretty weak stomach, so I think that's a good testament to at least. And it's probably not bringing the water up to the standards that we have here, but anything is better than drinking the water straight out of the river.
If I could just follow up to ask, your next trip, you're going to bring in 26, set up 26 filters, and thinking about the number you did in your last trip. Do you bring all the equipment with you in all the boats, or where are you getting the barrels and all the tournaments?
So we're getting everything locally, or somewhat locally, at least in Peru, in the city of Iquitos. So we're getting everything there, and then slowly boating everything to the different communities. So we're not getting anything from here, but yeah, that's how we're.
When we went in May, everything had already been delivered before we got there, and that's something that I guess Dr. Gilmore set up ahead of time. So all of the barrels, they're repurposed so that we get them at like a discounted price. They come from the city of Iquitos, and they're able to ship them up the river to the village. It's a good question about this village because they said it's like a 10-hour hike to get there, and I honestly don't know the answer to that question. That's something Dr. Gilmore probably has figured out. Anything else?
I just wonder if packing in a microscope might not be practical, but there are the little field scopes, but to show the villagers, when you look at a water under a microscope, see all the things in there that you don't know there.
We actually did talk about that.
Well, we talked about it. We just couldn't find a microscope in time to go.
It's kind of a hard concept.
Definitely.
Those little things you can't see.
Mm-hmm. Yeah, it's a good suggestion.
Other comments, questions? All right, thank you very much.
Excuse me, this is Sherry in the Vinon, and I just want to remind everyone
that any questions in the audience, you will need a microphone so that, because we are recording.
Okay, thank you. We had forgotten that. Okay, so in keeping with our interdisciplinary approach here, we're happy to have a representative from the College of Health and Human Services from the Department of Global and Community Health. And so Shannon Snyder is going to present on environmental racism, water, and the class divide.
Hello, everyone. So thank you to the Mason Water Forum for inviting me to speak today, and to all of you for being here for this presentation. As I watch some of the other presentations, it's clear that you all have to do a lot more math than we do over in CHHS. I'm a two-time graduate of GMU. I've been here for a long time, since 1988. These buildings didn't exist. I have a BA in political science and a master's in interdisciplinary studies and concentrations in global and community health and anthropology. I've been an adjunct instructor since 2013 in global and community health, where I teach health and environment, health and literature, and health leadership, ethics, and advocacy. And I'm also a cultural studies PhD student, planning to develop studies in the fields of biopolitics, environmental racism, and cultural indicators of health behavior. So a lot of what you all spoke about today resonates with both what I study and what I teach. My presentation today centers on the topic of environmental racism, although very much in brief. It's just a snippet of the topic of large, and the issues I'll mention today are certainly part of a larger conversation and some of the conversations that are already around the tables now. So I will discuss the idea of environmental racism and then relate it to water and then the disproportionate to access and quality. So before I go into racism or even how we can dialogue it in the United States, I want to talk a little bit about my field studies in water scarcity and health in Brazil and where I focused my thesis work. So during this work, I theorized for Maceió, Brazil, what is already a common issue in other parts of the world, such as Peru, and certainly Cambodia and Senegal and many of the other places where some of our colleagues and students have studied, and that's that access to clean potable water directly impacts human health. So I set out to find what the disproportionate impact was in terms of socioeconomic level, but particularly the urban poor. And then although I unquestionably found the link between poverty and water and therefore health, I also found indicators for both race and class as well. Click. Okay. Not click. How do I go back? Page up? Okay. I'm using the other. Okay. Using a clicker here. Okay. So for my field study in Maceió, although the common demographic for lack of access to Brazil was low income and Afro-Brazilian, this by no means explains the race and class association to water in every part of the world. We also have to look at ways we're defining and thinking about race and pay attention to theorists such as Gil White, Gilroy, Foucault, and Willis, among others. And the assessment that race is more than skin color, it's more than DNA, it's deeper than biological, and we have to understand race as a social construct. So this also brings us to the question of class, socioeconomic, and SES, and economic indicators that also price groups of people whom we refer to as vulnerable populations out of water. When we think traditionally about water scarcity, we think about drought and rain and lack of rain and dry seasons, and that is correct and appropriately known as physical water scarcity. However, economic water scarcity is an entirely different problem. It's when there is enough water, but due to lack of infrastructure, from problems such as construction, privatization, corruption, degrade water and conflict, etc., clean water is failing to reach the communities. These issues are far too complex to explain in 15-20 minutes, but we can break this down a little bit further from a global look to local or U.S. issues in the same discourse. So the studies on class and race in terms of disproportionate impact related to water in the U.S. are also wanting. A lot of our water projects do center in developing countries, and we sort of forget that we have a growing water problem here in the United States. The PAC Institute published a telling water policy paper in 2013 outlining some of the gaps in water infrastructure in certain populations in the U.S., and they aptly labeled these environmental issues. So they highlight issues such as instances where low-income communities and communities of color are disproportionately burdened by water hazards, legacies of discrimination in land use planning, and cumulative risks and impacts to low-income communities and communities of color that are overlooked, and these are just a few. So in fact, while most of the domestic conversation here in the U.S. involving water highlights issues of climate change, and I look at Dr. Dan there, particularly in terms of the arid Southwest, we know that we're dealing with droughts, and we've heard, it's been very much part of our conversation. We have to look closely at what an overlay of water supply and poverty, race, and income strata also look like, particularly in places where climate is not necessarily the current overriding concern, although currently climate change affects almost all parts of the United States. But a fairly general poverty map looks something like this, and we can overlay hypothetically a transparency of poverty map over a scarcity map and start to visualize some correlation between the two. And if we had access to some transparencies for highlighting race, we'd be able to make additional correlations. And what I'm saying is that some of the places where we have extreme water scarcity, we also have extreme poverty. But it's not until we see detailed quadrant maps that highlight counties or neighborhoods or even some of the inner city places that we know as wards that we start finding common denominators that also point to class and race and that are not prevalent in, to be clear, our control groups, which would be upper class white communities. Even in the arid Southwest, where 7 states continue to withdraw water from the Colorado River, which cannot replenish at its source, golf courses, resorts, hotels, and wealthy gated communities still enjoy green grass, treated waterscapes, and potable municipal water. But again, this is only a snapshot of the pattern. It doesn't touch our oil spills and their vulnerable population, shut out of medical claims because of their pre-existing conditions. A lot of the pre-existing conditions are from poverty-related illnesses, and there's disclaimers on the medical claims saying that if you have pre-existing conditions, you're not eligible to get money from the oil spill fund. And then, of course, we can insert here Paul Farmer-esque theories of diseases of poverty of the poor. So, for example, like this picture here, when I was at an oil spill in Battle Creek, Michigan, this particular family suffers from scabies due to their living conditions. But because the effects of the oil spill also compounded some of their health issues, they wanted to submit claims for health care, but the claims were denied because their living conditions and current health conditions already precluded them from supporting new claims. And then, of course, anyone that agrees to a settlement, it's not going to cover now the future illnesses and medical concerns. So my study of the 2010 Enbridge oil spill in Marshall, Michigan, and the nearby Battle Creek, pretty much everyone that I met were victims of both race and class variables, whose only difference between a future of health and one of unknown adverse health effects was their economic ability to move out of town. So a lot of us look at disasters such as Chernobyl or major oil spills and we think, why don't you just move? But when you're talking about vulnerable low-class communities that are in poverty, it's not that easy to pack up and move. Most of the people that I met, primarily from impoverished trailer park communities or government relocants from various natural disasters, including Hurricane Katrina, they stayed, and 5 years after the disaster, now suffer chronic seizures, COPD, and unfortunately some of the people that I interviewed have now passed away. So there's also not enough time to delve into some of the adverse health effects that are known about oil spills from the long-studied epidemiology of the Exxon Valdez, because we're now in neighborhoods, not in diluted bays and oceans. But in the essence of time, however, today's summary also leaves out other water scarcity issues, such as those on Native American reservations, which I've already also traveled to and studied, and water quality problems on U.S. military bases, where some of America's most selfless people have lived below poverty level and they're drinking poisoned water. And those that live downstream from mountaintop mining and the countless unresolved EPA Superfund sites located within walking distance of some of our neighborhoods and schools. They share our aquifers and share our source water and groundwater, all which really have zero guarantee of not leaching or compromised due to like cracks in landfill liners, rusty and outdated pipes, unattended containment booms, and more. So the fact that you guys are using PVC is really important. Latin America, for example, has been trying to slowly but surely change over from metal piping to PVC because of the rust and the holes that exist in the piping are causing pathogens such as Giardia. So even if they have a fantastic water filtration system and water is leaving the drinking water facility clean, it's not reaching the end user in that condition. And so the prevailing disease, giardiasis, is very common in Brazil, even though their treatment facility looks very much like ours in Fairfax, with the exception of their end process is chlorination, and we have the extra step of ozone, but still it's not reaching the end user in the condition that it leaves. But of course, I have to mention our biggest news now, which of course is Flint, Michigan. And the key argument is that citizens were not told about the hazardous chemicals and contaminants in their water. There's the big conversation about this, assumability that it was because they're poor and white or poor and black, while key privileged groups in the government and the communities knew to drink bottled water or safe potable water sources before they were forced to tell the truth. And even late as last night on WTP, there's a big, blame, who's to blame and who's to be fired and all that. So why the cause for concern? Based on an American Public Health Association webinar that I just attended Wednesday of this week, presented by experts such as Dr. Susan Buchanan. She is a pediatric environmental health specialist. And Ellen Green-Moten, she's not only a Flint resident and a community outreach coordinator, but she's also a longstanding member of APHA. The answer is lead. So aside from the deplorable community trust issues that already exist because of the racial divide, it's going to take a lot of sorting out, but studies already indicate that the key affected population will be, and already has shown to be, children. So from the graphics here, you can see that briefly the overall lead numbers, what the overall lead numbers look like for the U.S., and they've declined through the decades thanks to regulation and product reformulation. We're trying to put less lead in things, and as we remodel houses and so forth, we have protocol in place for PPE and so forth. But the red line, which is the level now indicated in Flint, is some of the highest numbers we've seen in about 35 years. Since children have a different toxicological dose response to lead than adults, they're smaller, obviously, they have more surface area in their skin, we can see that why this group is in trouble. Their water mixed formulas and other similarly prepared foods also mean that they consume an almost 80% water diet. So studies have shown that a correlation to other countries that have also had long-standing lead problems, such as Mexico, the neurological and ultimately intelligence effects of lead in children shifting the IQ points by several in a negative direction. Even though it seems like a fairly small shift, it has larger implications, relegating an already economically challenged population to a future of less than adequate opportunities, including jobs that require higher intelligence and capabilities, not to mention the long-term physical effects that can be associated with exposure to lead, such as aggressive behavior and hearing loss. Lead is also some indicators for below the stanine growth in children, so their body growth, their height is not increasing as quickly as those not exposed to lead, as well as a correlation to delinquency in school, and then other cognitive delays and disparities. So again, this is already compounded by the income and geographical associated nutritional shortages, less than adequate health care, disparate school systems, et cetera, that are already failing children in places like Flint, Michigan. So I'm going to leave you with a definition to think about as you watch the news or continue to explore these conversations. And I'll do here something that I always warn my students not to do, and that's to take a definition from Wikipedia. But the definition for environmental racism was good enough. Although not comprehensive, we can also put this definition in reverse, so to speak, where we're placing hazardous environmental conditions serendipitously and without concern in the backyards of vulnerable communities. And we see this in other things too. We do illegal dumping, we set up dump sites and landfills, so other things too that do not necessarily directly relate to water. And then, these continue due to politics, dishonesty, sometimes corporate greed, et cetera. And then also by accident. But the only difference is that sometimes these accidents are not being cleaned up. Sometimes they're being shifted immediately to Superfund sites, and we all know that financial issues regarding Superfund, et cetera. So, and then finally, any students here, I obviously invite you to look at, human and environment courses. And then as I move through, studying environmental racism and some of these other human links, I'm more than happy to have anyone contact me. I enjoy dialoguing about all these topics. And then I also have a little organization called Water Health Educator. It's a repository for students here at GMU to do some writing on water. And I publish their writing there. So some of your colleagues, you might recognize their names as you go through some of the links. So any questions?
Microphone, so voice from above.
Sorry.
Thanks, Shannon. I think we could. Is this come? Okay. We could all benefit from looking at this issue more closely at Mason, given people coming from all over the country and all over the world. I was wondering if you've had any exposure experience or interest in looking at within counties, like at the smaller scales within municipalities. Like I was at a environmental forum or breakfast over at Brian's last weekend. Everyone who was there, pretty much looked like they were from my ethnic background, and I thought there are a lot more environmental problems in our area than are being captured by my socioeconomic status, age, and ethnicity. Have you had interactions or insights on that from either Fairfax or other localities?
Yeah, and I mean, not necessarily in terms of water, but like, for example, I was surprised. I had one student that wanted to look at illegal dumping in Fairfax County, and who knew that we had a problem, because most of us are like, well, it's not in our backyard, so we don't have to deal with it. But as we do stream cleanups, like we have a really big one, it's the 11th annual Occoquan River cleanup coming up in April. We're finding things like tires and motorcycle parts and all kinds of things that are people will in order to avoid having to pay for waste removal, they will find a hill and they'll just kind of pitch things downhill. We've actually been at a cleanup where people were actually actively throwing stuff down to the stream that we're like trying to pull stuff out of. So I mean, we definitely have smaller scale issues. And then of course when I was at both the Deepwater Horizon and then Battlefield, Michigan, obviously two big oil spills, but totally different demographics. And so I think it's important for us to not, generalize too that, there's not specific community needs. Like we're seeing in Flint, there's very racially charged. What we saw in Battle Creek was very class and income charged. So, there's definitely, there's like everything really has to be looked at carefully in order for us to treat it. But yeah, there's stuff happening right around here that, we should know about. We're the academy here, so yeah.
I look forward to exploring that more with you at some point.
Absolutely.
Other question or comment for Shannon?
And thank you guys for the work that you're doing with WASH. It's a very important program. And the sustainability part is very important. The other thing that that we always caution about is that, it's very common for us to go into other countries and drop a bunch of like plastic or things that expire after a couple of years, or like water straws that are only good for 1,000 uses. So for things that can be rebuilt and then of course sustained by the people that live there, that's the best way for us to help globally as well, and education.
I have a question for you,
Oh, yes.
because I'm seeing a parallel between environmental science and policy and global health, in that some accuse our realm of being something of doom and gloom.
Oh, yeah.
So I'd like to know what makes you hopeful in your area.
Well, I was class optimist of my senior class, although that was like, 40 years ago or something. But, the classes that I teach to, particularly environmental health course, as I'm talking about it, we do see like the pattern of, this is all very like doom and gloom. This doesn't sound very positive. So I always try to end the class with like, okay, what is our mitigation? Like, what is our plan here? What are our solutions? So even when we're talking about like the world water crisis and how, even though we're making advances in clean water, but sanitation lags behind, we can still talk about like, how much good we're doing. And then I try to really empower students and, of course, my colleagues so that we don't feel like it's, there's just too many people, like it's just, we can't do it all. It really is each one teach one, which is also what you guys are doing, and just, one step at a time. But sustainability and GMU's process for sustainability and sustainable approaches is the most important. That I think that is a way to be positive, is that, we're not just trying to drop in with like one-time ideas. What we're trying to engage here is conversations of things that can be long-lasting. But yeah, there is a bit of, it's a little sad. Yeah. But because we're talking about real life issues. I mean, we can pretend that the Kardashians are all we have to worry about, but, that's not reality. So what we're doing here is important, and that has a little bit of negative conversation involved. So I agree.
Okay, we have two more presentations this afternoon. One of our presenters fell ill, and I didn't think we would have the last presenter, but the cavalry has arrived, and so we do have our final presentation as well. Let's see. We're in the desktop. So our next speaker gets to wear two hats because she's a graduate student here and she also works for USGS, and I have to put a plug in for USGS because the Lee Town Science Center was the very first field trip the Mason Water Forum took, and now we have the Lee Town Science Center people here, so there's this great connection between us. So I recruited Cindy for this.
Yeah. So I'm Cindy Adams. I'm a master's student here, and I also work at the Lee Town Science Center. I work for the Fish Health Branch. We're located out in Kearneysville, West Virginia, which is out by Charlestown and Shepherdstown, if you have no idea where that is. So we do a lot of different kinds of research. I am a molecular biologist, and so I'm going to talk to you about the molecular techniques that we use in assessing ecosystem health. So I'm going to talk to you about what ecosystem health is, and then what molecular methods we use to study that, and then the objectives of those molecular methods, and then I'll use Hurricane Sandy as kind of a case study and give you an example of applying those methods, and then a couple of other examples. So what is ecosystem health? So it's a way to measure a system's ability to maintain structure over time when there are a lot of external stressors, whether they're contaminants or hurricanes or other events. And so they can be it's kind of a subjective measure. So if you see a healthy fish, does that mean your ecosystem is healthy? Or if you see fish that have different kinds of tumors, does that automatically mean that your ecosystem is not healthy? No, not necessarily. So there are different levels of assessing ecosystem health, and there are a couple considerations there are a couple things you need to consider when you're looking at ecosystem health. So you think about the current status of the system of interest. So you might think about what kind of human development and is there agricultural runoff around the aquatic ecosystem that I'm looking at? Or is there potential that there is wastewater treatment plant nearby? And then the really key aspect is to determine a useful index of health that's practical, quantifiable, and current. And there are a lot of different methods that are available. So they range in what they tell you, though. So you have subcellular responses. So I know these boxes are a little bit small, but they're very specific. So subcellular responses are the molecular methods that I'm looking at. So while the significance is small, it means that I'm looking at an individual marker and what that individual tells you about the system. So what's important there is that an individual can tell a subcellular response, like using a molecular method, can tell you what happens immediately. Whereas when you're looking at a population die-off or population change, these things happen over a greater span of time, typically. But the importance also is that we combine all of these methods to get a better picture of what the ecosystem health actually is. So the objective of using molecular methods are really to give us an early idea of what is going on in an organism. So we study fish typically, but you can study a number of different organisms and identify the molecular aspects. So what molecular biomarkers can we measure? So you guys, I don't know how much you know about molecular biology, so sorry if this is boring, but so if you all remember that everybody has a genome, and that is comprised of DNA. And so your DNA is what ultimately is going to tell your cell how it functions. And the in-between step there is RNA, and that's going to be the message that tells your cell how it is actually, what protein is going to be made, and so therefore what functionality. So like if I need an immune response, then I need to have the DNA made into RNA and then send off a protein immune response. So looking at the first step, DNA, so one thing that we do is looking at the microbiome. And so it's a way where you can take a single sample, so say the intestines of a fish, and you want to know everything that fish ate. Well, so everything that is in there, inside the gut of the fish, has a genome. And I can say, okay, well, I want to know, like, I know that this part of the genome is in every single organism that I want to know inside of the gut. And then I'm going to look at that part of the DNA, and those are all, they all have an associated sequence of DNA with them from the genome. And so therefore you can build a community based on all the individual sequences of DNA to figure out what kind of either microbial or any other kind of community, or what kind of plants did the manatee eat, or a number of different issues. So then the next step that we can look at is the RNA transcription. So RNA, we can build a transcriptome now with new sequencing technologies. And so what that means is that you have a genome, but not your whole genome is always expressed. So we want to know what part of that is actually being expressed. So do I have immune response, or do I have something that is responding to chemicals in the water? And so you have all of these, you can see on the pie chart, all of these are all different areas of genes that might be active. And so some of the bigger ones there are ones that are essential to cell function. So every cell has to survive, right? So of course those are bigger. So what we're looking for typically are things that are much smaller slivers of this. But having this big picture is really useful because then we can identify what portions of this might be important in looking at a response in our species of interest. So do we always have to build a transcriptome? No. But because we can also use RNA pieces where we know that these pieces of RNA belong to a certain gene, and then we can look at exactly how many copies of that gene are in a cell. And so this is an example of real-time PCR where you're able to count how many copies of a gene are expressed. And so if you have a group of fish that might be exposed to contaminants, they might express one gene over another of a group of fish that was not exposed. So hopefully this will make more sense when I give you my example of Hurricane Sandy. So in the case of Hurricane Sandy that was talked about a little bit earlier, we had 3 different study areas, and we looked at the bluefish, the blue mussel, and the ribbed mussel. And those are 3 species that are resident species to the area. And we had historical and chemical data to go along with those 3 species. And so that was part of the reason of why we picked those species to study. So obviously we knew that there was a weather event, and so one of the concerns with the storm was that contaminants from wastewater treatment plants and such were brought back into the water from the storm. And so we had people looking at all different levels of the response. So if you remember on the slide of where I had all the different levels of the subcellular, molecular to the community response, we had people looking at all these different levels of markers. So we had one of those markers being histology, which is looking at a tissue and slicing up a tissue and seeing, okay, does this look normal? Knowing what a normal fish tissue looks like and comparing that, and also looking at how bioaccumulation of different contaminants in fish tissue, mussel tissue. And then I looked at the molecular biomarkers. So the microbiome is a relatively newer biomarker. And so we looked at it in the blue mussel, and we were looking at the community structure of the microbes in the intestines of the blue mussel. And so we were looking specifically for microbes that might have been associated with fecal content or wastewater effluent that might be in the water. And we didn't find any evidence of those microbes present in the blue mussel intestines. But it was interesting nonetheless because we did identify that 85% of the community was a symbiont that was living in the mussel. And so even though, so it was interesting because we were able to say that we didn't find a difference we didn't find evidence of contamination affecting the microbiome of these mussels, but we did identify a new organism, and so it kind of opens the door to studying the organism on a higher biological level, so identifying how that organism actually works with the blue mussel. And then, so we also looked at the gene expression. So this was the RNA factor. So what is actually happening in the cell functionally? So the CYP1A on your left side is a gene that's responsible for transforming contaminants. And so this was differentially expressed. And so it doesn't necessarily mean that the fish were exposed to contaminants from Hurricane Sandy, though. So because we had the contaminant data also, we know that previous contaminant data was similar, and it showed that the accumulation in the tissue of the bluefish was similar. And so there's actually more concern of industrial runoff than there is that the storm brought any change. And then this is another example of a gene expression profile, and that's for a gene that is involved in, that provides microbial resistance. And so that one turns on and off very quickly. So it really is very highly dependent on when you sample your fish. So these were the results of the Hurricane Sandy project, and so piecing them back together with the contaminant data and with all the other data is still a work in progress, but it's an important part of building a bigger picture because the molecular methods can be an early identifier, and they can really, before you see any changes to your fish. So I don't see any lesions on my fish, I don't see any tumors, but there are changes that are happening, and so it's something that we don't know necessarily a cause and effect yet, but it's something that's being investigated, and the more data we have, the more we'll be able to draw these correlations. So the importance of these methods are that they're really a tool for any species, and it's not just in the case of Hurricane Sandy that we can use them. So I mean, we use gene expression profiles in a case like the chemical spill in the Elk River and looking at how fish were affected there. We did some studies of hydrofracking, so if the salt water is coming out, how is that affecting not only the gene expression of your fish, but how is that affecting the microbiome that might be a protective layer on their gills. And let's see. Yeah, so that is it. Yeah.
So I have good questions. Fun with the questions now. Out there, one of the posters dealt with the effects of precipitation levels on malaria, and I was wondering if you thought some of these same techniques might be useful for us to do early detection of malaria, either in vector species or other waterborne disease pathogens, kind of looking at the human health side of ecosystem health, or One Health as they're calling it now.
Yeah, I think, you could definitely do that. And there are tried and true methods of collecting things like that. I mean, if you take a filter in the water, or you can collect water and filter it, and then, so it's what we call eDNA, and you can extract the DNA from that, and you could detect the vectors using numerous methods, but it would probably be pretty cost effective too. I'm sure there are markers that have been developed for it, actually. I would think, yeah.
Anybody else? Okay, we're going to get Heather set up here with her presentation, our last one of the day, but I will put a plug in. We have the poster awards coming up, and then we thought when this thing ended, we could send you all out into the lovely Fairfax traffic, or we could show you a short film called The Ribbon of Sand, which features the Outer Banks of North Carolina and Cape Lookout. It's only a half-an-hour film, so if you don't want to go out into the traffic and you want to relax a little bit, have some more snacks, leftover lunches, we're going to be screening that film. We're going to be screening it in room 162 because people have reserved this room for tonight to set it for tomorrow, so we didn't really want people barging in on us, but I doubt they'll be here, but we thought we'd go to that room. We figured it would work. So Heather Walsh works with Vicki Blazer, who was ill, and we do appreciate you folks coming down at the last minute and filling in. And I believe you work with Vicki enough, so you're going to talk about contaminants of emerging concern in fish health. Great.
Title didn't change too much. Okay, well, I'm Heather, and I'm also a PhD student at West Virginia University. So I'm talking about chemicals of emerging concern and fish health. Chemicals of emerging concern are basically any kind of chemicals that will enter the waterway. PCBs, PHs, chemicals from like industry, which those are pesticides, herbicides, your agricultural runoff from roads too. Recently, the recognized effects are endocrine disruption from exposure to low concentrations of these contaminants. These chemicals can block the effects of hormones, hormones that are normally in the body. They interfere with functions such as growth, metabolism, and reproduction. And they can also mimic normal hormone function by adhering to the hormone receptors on a cell. Here's a couple pictures of examples of where EDCs or CECs come from. You have industry, concentrated animal feedlot operations, pesticide use, herbicide use, wastewater treatment plants. So in humans, CECs have been known to affect humans in negative ways. One example of that is the synthetic estrogen that was prescribed to pregnant women in the 1940s through the 70s in order to prevent miscarriages. It was found out that it didn't work, but the effects were long-lasting. Women that took this estrogen while they were pregnant, their daughters have been shown to have a type of rare cancer in the uterus, birth defects, infertility, and pregnancy complications, and in some of the sons, testicular and genital abnormalities have been seen. Fetal deaths have been linked to pesticides. A birth defect of the penis and breast cancer in women are just a few examples. There are many more. And this is a really good book, Our Stolen Future, that I think it was written in the 90s, but it's a good example of the effects of CECs on humans. Sources are such as I described before: wastewater treatment plants, industrial effluent, stormwater runoff, agriculture, leachate from landfills, gas extraction, such as Marcellus Shale, and phytoestrogens, which is one that people don't often think about. And the examples of these are soy, flax, wheat, barley, nuts, sesame, and even algae in the water. Here's some pictures of how CECs can directly enter the waterways. One that we see around us quite often, since we work in the country more or less, are cows that have free access to get into the water. I see that all the time. Drives me crazy. We actually have right the stream that we get our water from, the farmer next door lets his cows go in. So, and here's another example where there's piles of litter along the banks, and so during a high storm event, that waste just goes right directly into the river. Wastewater treatment plants release pharmaceuticals that humans take, such as birth control, hormone replacement therapies, antibiotics, Viagra, Prozac, painkillers, also personal care products, such as antimicrobials, soaps, detergents, fragrances, and sunscreens and DEET. Polybrominated diphenyl ethers or flame retardants are a big one. BPA, found in plasticizers, epoxy resins, and thermal paper. Thermal paper is a big one. I often, when I go to the store, I don't think the people that are, the cashiers know what they're handling. And as soon as I get that piece of paper, I'm like ready to throw it away. And PCBs from industrial coolants and lubricants. This is some of our data, and I just put in here to show what happens after a big rainstorm. Here you can see examples of just a normal day, the levels of atrazine, like June 8th, and then June 11th there was a major storm. And then you go a few months, and then down there, April 30th and May 16th, you can see the level, the spikes in atrazine, these herbicides, metallochlor and simazine, after a high rain event. And so these are times that we often like to sample, and this is a sensitive time for fish, especially April. The fish that we sample are smallmouth bass usually, and this is when they're spawning. So when they get, and they're spawning, they're stressed out, they get hit with rainwater that's entering the waterways that's high in contaminants, and it can have a very deleterious effect. Many of these toxins were produced to have a biological effect, and so many affect they were produced to have a biological effect on humans, more or less, or as an herbicide to kill off weeds or insects, but they affect non-target organisms, such as fish, at very low levels. So you get this lack of a classic dose-response curve. You have your beneficial dose, and then it reaches the hormetic region, where there's a threshold, and suddenly it becomes toxic. I have an example. This happened, there was a major fish kill in the Conewago Creek in Pennsylvania last year, and it happened as a result of a chemical and fertilizer plant that caught on fire. What they believe happened was that after this plant caught on fire, it released a lot of contaminants such as nitrite, nitrate, and total organic carbon. Of course, these things are always present in the water, but this acute fluctuation of these chemicals was very damaging to the fish, especially the nitrite. And so you have these levels that are normally present, and then when they're hit with a high dose, it can kill them. There's a lot of complexities that occur with CECs in wild populations. It can influence the endocrine and immune systems, chemical communication and feedback mechanisms, multiple contaminant exposure routes. Fish are exposed to these contaminants in the water that they're swimming in the sediment that they're making their nests in, and the food they're eating. As a fry, when they have a yolk sac and they're using that as nutrients, or like for smallmouth bass that eat smaller fish, and the biological effect accumulates up the food chain. Then there's short-term exposure at sensitive life stages, and this we see in smallmouth bass that are induced with intersex. They likely become intersex fish at a young age, and it stays with them their entire life. Complex mixtures of CECs have additive effects, and the persistence of the effects can last for years in the muscle tissue, for example. So fish have been used for decades as indicators of exposure to estrogenic chemicals. As I mentioned before, the intersex, which is testicular oocytes, or male fish that have female eggs. And as like I said, it's usually induced, what we believe, in early life stages. And the severity is known to increase with increased exposure throughout their life. Another indicator that we often test for is vitellogenin. This is an egg yolk precursor. The exposure to estrogenic compounds turns the gene on in males. So we sample the plasma to detect levels of vitellogenin that's circulating in their systems. And this is more indicative of a recent exposure, weeks to months, as opposed to a chronic exposure such as intersex. Here's some of the health issues we see with fish. We have mucoid lesions, the top left, yeah, that's for you guys, top left corner. Small, round, raised little lesions over here. Large lesions such as this usually is associated with like a bacterial infection. Same with that one of the tail. And in Pennsylvania, we're seeing a lot of smallmouth bass. I call them Holstein fish because sometimes their whole bodies are covered in just like these large melanistic areas. So that's a little bit of what we've seen. Cynthia put some other pictures up of some different lesions that we've seen, such as lip tumors and things like that. So here's a histology picture of male fish that has intersex. All those dark purple are eggs. And it's the immature oocytes that we usually see. We've never seen them big enough that they would actually be able to be fertilized by males. So yeah. So these fish are swimming around, and there's multiple ways that they become stressed, especially, as I mentioned before, in the spring when they're spawning. Is such a sensitive time for them. They have an integration of effects from the climate, temperature changes, infectious agents such as parasites, bacteria, fungus. They're exposed to the sediment, physical and habitat alterations, nutritional factors if they're not getting enough to eat, other invasive species like the snakehead, contaminants, water quality, such as like your nitrites, nitrates, phosphorus, and all these contaminants and these effects can also have epigenetic effects on the DNA that aren't passed down through genetic breeding. It's changes to the DNA caused by an outside source such as contaminants. So we use fish as integrators for aquatic system health. They're constantly exposed to all these stressors in the water, sediment, and the food source. They're integrators of these effects over time. The stressors include complex mixtures of chemicals. It's hard to test for these things because we don't know what these mixtures are. We can only test one chemical at a time to see what it does. You have climatic effects, infectious agents, and many others. And as I've stated, the contaminants can act synergistically. And there's also complex interactions between contaminants and then fish that become infected with parasites and other pathogens that can cause immunosuppression in fish. So some of the fish health assessment methods that we use are at the organism level. We go out, we sample fish, we look for gross abnormalities or macroscopic. The condition factor organosomatic indices from the liver and the testes to see if they're developing properly. We also look at the tissue and the cellular level with histopathology We look at their immune function, and that's some of kind of, Cynthia kind of hit on that a little bit, and parasites and pathogens, and we also look at the molecular level. Soluble immune factors such as cytokines, hormones, we look at the reproductive hormones and thyroid hormones, and proteins such as vitellogenin, and we also look for molecular markers such as mRNA or DNA damage. One thing that I hope to be doing here in the near future is to develop molecular markers or biomarkers of intersex so that we can we'd like to get an idea of when they're induced as being intersex fish. So here's an example of one of the spawning studies that we do. The smallmouth bass spring spawning study in the Potomac, we took discrete water samples, but no estrogen hormones were detected. However, atrazine and metolachlor concentrations correlated with prevalence and severity of intersex. Total biogenic hormones and plant sterols in sediment correlated with prevalence and severity of intersex. The end result was that intersex severity and prevalence correlated with agriculture and animal density, like concentrated animal feedlot operations. And so that's kind of interesting because a lot of people want to blame wastewater treatment plant effluent, or where we sampled, where this was done, there's not a whole lot of industry. It's either wastewater treatment plant exposure that the fish could be swimming in, or agriculture. So with herbicides, atrazine has been associated with intersex in frogs, although it is not thought to bind to the estrogen receptor. It has been shown to alter phytoplankton and algal populations, increase trematode infections in fish, and cause immunosuppression. As I was talking before about the algae as having estrogenic effects, microcystin caused reproductive impairment in female zebrafish after long-term exposure. All right, well, with that, I'll take any questions. Yes.
Hi, great talk. I saw you showed histology slides, and you said, well, these eggs are not large enough to really develop. Do you have, perhaps from your studies, any evidence of changes in the behavior in response to those more histology type changes? Or?
No, we haven't seen, not that we've observed, no.
Okay, thank you.
You're working on, you've got a brown bullhead study somewhere too, don't you? You've been working on?
I've looked at the histology of them. I'm not sure where your question's going to go.
So I don't even know where this is, and I'm not sure if you're able to tell us where this is right now, but I believe there is a significant situation with melanistic tumors.
In Vermont.
Okay.
Yes. They haven't figured out any kind of cause of the tumors yet, and that's what Cheyenne's working on that, looked at the histo, and they're finding these brown bullheads with these awful-looking tumors on them, mostly lip tumors and some body, and they're melanistic tumors. And sometimes they've even seen the tumor spread to inside of the muscle and on the different organs of the fish. And it's interesting because these fish are in reservoirs in pristine areas. So, so they're supposed to be. So it'll be interesting to tease out what is causing these tumors.
I actually, I'm not sure it's necessarily a question, but I wanted to tell you that I'm thrilled to see that you mentioned atrazine. It's certainly like a pesticide that I don't think is talked about enough. We certainly talk about the other ones and the general nitrates and nitrites, and but that it's a horrible chemical. And not only does it have like the fish implications, but there's all sorts of human health implications. And it's been banned in every other country but ours. So of course this is like the environmental justice side of it. Do you all do any other, have you had any other studies that have pointed to atrazine? Is it primarily in your agricultural areas? Are you seeing it also, I don't know, how often do you run into atrazine as
Very often. I mean, it's lots of times when they do test water chemistry, it's there. Mm-hmm. We've done some work in the Great Lakes, and it was also there. Even where that Great Lakes areas are more concerned with industry, but it still shows up there too.
Yeah, I can't believe we're still using it. We had a representative from the EPA come to one of my classes, and I think she didn't know what she was getting herself into, but she didn't want to talk about atrazine.
Oh, really? Yeah. I love the EPA.
Yeah.
This morning, we saw DC Water. I don't know if you were here for the presentation, but they presented various different ways that they were looking at water quality, and one of them was they put they had a bunch of fish tanks, and they put water that they would send to our taps. They put fish in the fish tanks, and they just monitored them for, I don't know, if they died or if they looked strange or whatever. What do you think about that as a water quality indicator?
I would have to say, if I was doing it, I would want to look at it long term. And also, if they're not doing histology, I don't really know what good it is. Because if you're just looking at the external of the fish, a lot of times we sample fish and they look perfectly healthy. And their organs, sometimes they're riddled with parasites, but that's another issue. We don't know much until we actually look at the histology and also do some subsequent molecular techniques that kind of tease out if the fish really is healthy as healthy as it looks. So
I had never seen that before, and it just kind of surprised me. And I would have a similar response as you had. I don't know. They didn't say much about how they used them, but they did show the fish tanks. So this is one of the ways that we monitor water quality.
I may have missed a slide on this, and one of the dialogues that we have about drinking water is all the things that, certainly we have a list of the TMDLs of, chemicals and contaminants that are allowed at the what do I call it, the non-harmful doses and dose response. But it's interesting that you also mentioned medications and all of the stuff that we're putting into the water, including some of our antidepressants and things like that. So I'm just kind of curious because we've noticed regionally that there are links to people that have high levels of Prozac in their bloodstream, for example, that have never taken the pill because of the water that they're drinking. Are you seeing some of these numbers in fish for medications and things that shouldn't be in fish? They're not.
We haven't, but there's two studies. I think it was one in New York and one that recently came out. I think it was Washington State that they found. This boggles me. Cocaine. I think OxyContin. And I forget what the third one was, but yes, there have been examples of that where they find those in really high levels in fish. So. And then we're eating the fish. Yeah, people that aren't. I'm always oh, don't eat the fish out of there, and they're really? I'm I wouldn't. So, yeah, people, and this kind of links back to what you talk about. Around where we live, we have a lot of Hispanics, and they fish the rivers and they eat the fish, and I don't think they have any idea that there are limits on fish consumption and things like that. They might not speak English and they don't know,
Other comments, questions? All right, thank you, Debbie. You should be proud of yourself. Okay, I've got, we promised the students we enticed into creating posters and presenting them here that we had cash prizes for them. And we weren't kidding. So we have 3 $100 prizes to award and 3 $50 prizes to award. So, and thank you to all of you that got pressed into being judges and our talliers and compilers and those that figured out who won what. They did a super job. So we have a couple of different categories here. We have a $100 award for Best PhD. That's to Romulo Oliveria. So up and get your magic envelope and know that there are tax forms in here that you have to fill out because even your $100 prize is not really free. We also have an award for Best Graduate for Anila Musam. So congratulations, Anila. And if you guys could stick around, we get a photo perhaps of all the winners that are here. And we have a Best Undergraduate Award for Samantha Alexander. Welcome. And then in our other awards, we have an award for Best Presentation for C.J. Schlick. Congratulations. We have the Innovation Award for the Best Original Approach for Akko Hedere, who I don't think is still here, but we can give it to his advisor. And then we have a Sustainability Award for Kristen Mosky, who I don't think is here either, but we will find her and get her award. So thanks to everybody who did take the time to do a poster and present it to us.